All right, let's look at our little practice test. So we want to simplify, and for problem number 1, we have the negative of the absolute value of -3. So the idea here is just to first execute the absolute value operation. So the absolute value of -3 is going to be +3. So you would just have the negative of +3, which is just -3, right? So the answer here is just -3. All right, for problem number 2, we're looking at the absolute value of -5 times 7 plus 2 squared. So the idea here is to perform the operations inside of the absolute value bars first. You'll notice that you have multiplication, you have addition, and you have an exponent operation. Again, if you think about your PEMDAS, to remember this, the exponent is going to have the highest priority, okay? So let me put equals, let me set up the absolute value bars. I'm just going to copy the -5 times 7, and then plus, that's not going to change. The 2 squared is done first, so that's going to give me 4, okay? Then inside of here now, I have my multiplication, and I have my addition. So what is the highest level of priority? Well, multiplication is going to come before addition. So we would do -5 times 7 first. That's going to give me -35. So let's write this as the absolute value of -35 and then plus 4. Okay, close that down. And then finally, we would do -35 plus 4. That's -31. So we would have the absolute value of -31. And then we can take the absolute value, which is going to give us +31 as our answer. For the next few problems, we're going to be solving for x. Now, these are going to be absolute value inequalities, and we're going to cover these in more detail as we get further into the course. For now, I'm just giving you some simple things to think about absolute value with, okay? So the first one is a bit of a trick question. So for problem number 3, we have the absolute value of x is greater than -12. When you see something here where you have absolute value isolated on one side and you have a negative on the other, you should immediately be thinking this is a trick question, okay? The reason is you can think about anything you want to plug in there for x, okay? Anything, doesn't matter what it is. When I take the absolute value, I'm either going to get 0, okay? Or I'm going to get some positive number, right? Remember what the absolute value operation does. It takes a negative and it makes it positive. 0 stays 0 and a positive stays a positive, okay? So if I think about this, no matter what I plug in for x, any real number I want, I take the absolute value of it, it's always going to be 0 or some positive number, and then 0 or some positive number will always be greater than some -12 or any negative number. So really the solution here would be all real numbers. Okay, so this one is just all real numbers. Okay, so keep that in mind when you see the negative on the right-hand side of an inequality problem such as this. You know that you're going to get a trap question, okay? You can also show this in interval notation. So from -infinity to +infinity, something like that. All right, let's look at problem number 4 now. So you're going to see this is another trick question. The absolute value of x is less than -8. Again, for reasons we just talked about, when you see this guy as a negative on the right-hand side and the left-hand side is simplified to just be the absolute value of something, you know you have a trick question, okay? The absolute value of x, again, will be 0 or some positive number. Can 0 or some positive number ever be less than some negative number? Doesn't matter if it's -8 or -22 or -5 million, okay? The answer is no, right? So there's no solution here. So this is no solution. So another trick question. All right, for problem number 5, we're told that the absolute value of x is now less than 7. So for this type of problem in general, let's just think about the definition of absolute value. If I had something like the absolute value of 7, what does that mean fundamentally? It means the distance from 0 to that number, in this case it's 7, on the number line. So from 0, I would travel 1, 2, 3, 4, 5, 6, 7 units to get to 7, okay? But also we know that the opposite of 7, or -7, so this is 7, but the opposite of 7, which is -7, has the same absolute value. It's the same distance from 0 on the number line, but it's on the opposite side. So let me use a different color here, and let me count 1, 2, 3, 4, 5, 6, 7. Okay, so let's think about what we have here. What number can I plug in for x such that I take the absolute value of it and the result is less than 7? Well, it's going to be anything in this interval, right? So I'm going to put a parenthesis here, and I'm going to put a parenthesis here to show that -7 and 7 are not included, but anything between -7 and 7 would work. For example, if I took -5, the absolute value of -5 is 5. 5 is less than 7. That's a true statement. I could take +6. The absolute value of +6 is 6. 6 is less than 7. But I can't take 7 itself. The absolute value of 7 is 7. 7 is not less than 7. I can't take something like 8. The absolute value of 8 is 8. 8 is not less than 7. So it's got to be within that interval there to where the distance, okay, from 0 to that number is less than 7. Okay, that's what we're looking for. So your solution here would be that x is greater than -7 and less than +7. So when you have a less than like this, it's always going to set up this way. If you had something like the absolute value of x is, let's say, less than 3, well, this would be x is greater than -3 and less than +3. If I saw something like, I know this board's getting a little busy. If I saw something like, let's say, the absolute value of x is less than, let's say, 10, well, this would be that x is greater than -10 and x is less than +10, okay? So this would be your solution graphically. Let me erase all this. And then in interval notation, I could put a -7 and then a +7. I'm going to use a parenthesis next to each because they're not included. All right, let's look at problem number 6. So this is the opposite setup. Here we have the absolute value of x is now greater than 9. So using a similar thought process to what we talked about in problem number 5, essentially, if I had the absolute value of 9, this is 9. If I had the absolute value of -9, this is also 9, right? So from 0 going to 9, that's 9 units, right? And then from 0, let me use a different color. So from 0 going to -9, that's also 9 units. So what I want is a distance from 0 that is greater than 9, okay? So it can't be 9 itself, but what I can do is I can put a parenthesis at 9 to say that it's anything larger than that. So for example, it could be 9.5. If I plugged in a 9.5 there, the absolute value of that, or the distance from 0 to, let's say, 9.5, that's greater than 9. Let's say this was 9.5, right? I would count 9, then another 0.5 units, so that is greater than 9. So this would work as a solution, okay? So I'm looking for anything that's greater than 9, but then also anything that's less than -9, okay? So let's get rid of this intermediate stuff here. That would not be part of the solution. Let me get rid of that. So this would be graphically what we're looking at. So x would be anything that is greater than +9, or, okay, you want to use this word or, x is less than -9. Again, if all this stuff is a bit confusing for you at this point, it's okay. We're going to go way into detail in terms of this topic later on in the course, okay? And then in interval notation, what you'd want to do is say, from -infinity out to -9, okay? And I'm going to use a parenthesis with each. You're going to use this symbol for the union, okay? And we'll talk about this later on again. And then we're going to have this 9 here, okay, with a parenthesis next to it, comma, infinity with a parenthesis next to it. All right, so now we want to find the distance between point Q and point R. So for problem 7, we see that point Q is given as -5 and point R is given as 7. So here's -5 and here's 7. So if I do this on a number line, it's pretty easy. I can just count. I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the distance between them, whether I count going to the right or going to the left, it's going to be 12, right? But we don't want to pull out a number line each time. So basically the formula for this is to, inside of absolute value bars, you just want to do a subtraction. And the order of the subtraction doesn't matter because you're taking the absolute value. So you could do -5 minus 7 like this, okay? So this would be what? The absolute value of -12, which equals 12, which we already figured out from this. So the other way you could do this, if you flip the order, you could say that you have the absolute value of 7 minus a -5. Again, minus a negative is plus a positive, so this would be the absolute value of 7 plus 5, which is the absolute value of 12, which is 12. Okay, so however you want to do this, obviously for a lot of problems, it's not convenient to use a number line, so you typically want to go to the subtraction method, and the order is not going to matter because you're using the absolute value operation. Okay, so now we're given that Q is -1 and R is 8. No need for the number line here. I'm just going to say the absolute value of -1 minus 8 would be equal to the absolute value of -1 minus 8 is going to be -9. And so this is going to be +9 as my result. Okay, so here for number 9, we have Q equals -3 and R equals -1. Again, I'm just going to do the absolute value of, let's do -1 minus a -3, okay, like this. And so this is the absolute value of, minus a negative is plus a positive. So let's go -1 plus 3, like this. And then this equals, we have the absolute value of -1 plus 3 is going to be 2. So the absolute value of 2, which is 2. All right, for problem 10, we have that Q is 12 and R is -15. So again, I'm just going to do the absolute value of, let's just go ahead and say 12 minus a -15, okay, like this. And again, minus a negative is plus a positive. So this is the absolute value of 12 plus 15 would be 27. And the absolute value of 27 is 27. Let's take a look at our practice test. We're told to solve each equation, and for problem number 1, we have the absolute value of x plus 6 is set equal to 1. Now for this type of equation, the first thing we want to do is isolate the absolute value operation on one side of the equation and then have a single number on the other. So in this particular case, we already have that. We have the absolute value of x plus 6 isolated on the left, and we have this 1 that's isolated on the right. Okay, so from here, what do you do? Well, basically, you're going to take the expression inside of the absolute value bars, and you're going to write that. So we'd have x plus 6. And in the first scenario, you just set it equal to this number over here. So it equals 1. So basically, just drop the absolute value bars. Then we're going to write our keyword or, because we're going to be setting up a compound equation with the keyword or. And then the next one, I'm going to drop the absolute value bars again. So I'm just going to take that expression and put x plus 6. But now I'm going to set it equal to the negative of this number over here. So in this case, this would be negative 1. So what I want to do is solve these two equations. And let's go ahead and do that real quick. On the left, I'm just going to subtract 6 away from each side. And so this is going to cancel here. And what I'm going to have is that x is equal to negative 5. Then I'm going to put or. On the right over here, I'm just going to subtract 6 away from each side. And again, this is going to cancel. So what I'll have here is that x is going to be equal to negative 1 plus negative 6 is going to be negative 7. So x could be negative 5 or x could be negative 7. Now, as I talked about in the lesson, there are a lot of ways to notate your solution for this. You could keep it like this if you want. You could write it like this. You could say x is equal to negative 7 comma negative 5. And then you could also use your solution set notation. So you could say negative 7 comma negative 5 inside of your set braces. Again, just get with your teacher in terms of what they want you to do. If you're self-studying, I tend to like this one, but it's really up to you. Okay, I want to check this one with you just so you get an idea of what's going on here. So let's go ahead and write this absolute value of x plus 6 is equal to 1 like this. And in the first scenario, let's choose negative 7. So let's choose negative 7, and let's see what's going on. So negative 7 plus 6 is going to give me negative 1. So I have the absolute value of negative 1 is equal to 1. Now notice that this number does not exactly match this number. But what's going to happen is the absolute value operation is going to fix that for us, because the absolute value operation is going to change negative 1 into positive 1, and so the left and the right side are going to be equal. So this would be 1 equals 1, so this works as a solution, right? Again, because of the concept of absolute value. So let's erase this, and let's erase this, and now if we put negative 5 in there, well, negative 5 plus 6 is positive 1, and the absolute value of positive 1 is 1, so you get 1 equals 1, so this works as a solution as well. Okay, let's look at problem number 2. So here we have the absolute value of x plus 2, and this is set equal to 8. So let's go ahead and say that we have x plus 2 is equal to 8, and then or we'll have x plus 2 is equal to negative 8. Again, we'll just solve these two equations. So I'll just subtract 2 away from each side of the equation here. That'll cancel. And what I'll have is that x is equal to positive 6. Then or, over here, let's subtract 2 away from each side of the equation. And let's say that x is equal to negative 8 minus 2 is going to give me negative 10. So basically, x can be 6 or x can be negative 10. Again, if you check this, 6 plus 2 is 8, positive 8. The absolute value of 8 is 8. Then if you put this one in, negative 10 plus 2 is going to give me negative 8. The absolute value of negative 8 is 8, so 8 equals 8. So both will work as a solution. Again, if you want to write this like this, I'll say x is equal to negative 10, comma 6. Okay, let's look at problem number 3. So this one's a little bit different in terms of the setup. Let's slide down here a little bit. So we have the absolute value of 9x plus 9 is equal to the absolute value of 2x minus 6. So two numbers or two expressions can only have the same absolute value if they're equal to each other or if they're opposites. So I could do something like the absolute value of 3 is equal to the absolute value of 3. This is 3 equals 3. Or I could do the absolute value of negative 3 is equal to the absolute value of positive 3, right? Those would be equal because this guy is going to flip to 3. This guy would stay to 3. So either way, you get 3 equals 3. So I'm going to use that same concept here and just say that in one scenario, I could just drop the absolute value bars. So I could say 9x plus 9 is equal to 2x minus 6. Then or the other scenario is I would basically drop the absolute value bars. So let's go 9x plus 9 is equal to 2x minus 6. And I've got to pick one of these. It doesn't matter which one. And I've got to apply a negative to the whole thing. So wrap it in parentheses and put a negative out in front. It can't be that you just put a negative to one of the terms. You've got to wrap it in parentheses and apply the negative to the whole thing because I want the negative of this expression. So I'm going to subtract 9 away from each side of the equation, and I'm going to subtract 2x away from each side of the equation. Let me slide this keyword or down a little bit so we have a little room to work. So I'm going to cancel this and cancel this. So 9x minus 2x is going to give me 7x. And this equals negative 6 minus 9 would give me negative 15. We can divide each side here by 7. And I'll say that this is going to cancel. X is equal to negative 15 sevenths. Over here, I'm going to apply this negative to each term inside the parentheses. So I'll have negative 9x and then minus 9. This equals 2x minus 6. Let's add 9 to both sides of the equation. And then let's subtract 2x away from each side of the equation. So let's cancel this and cancel this. And let's say that we have negative 9x minus 2x, that's negative 11x. And this will be equal to negative 6 plus 9 is going to be positive 3. And let's divide each side of the equation by negative 11. And so what we'll get is that x is equal to negative 3/11. Okay, so coming back up here, I just erase everything so it would be nice and clean. I'm just going to write the solution as x is equal to negative 15 sevenths. And then also you have negative 3/11. Again, if you want to use the keyword or, you can. I'll let you pause the video on your own and check each of these as a solution for the original equation. You'll see that they both work. Okay, let's look at problem number 4. Same setup as problem number 3. So basically I would want to drop the absolute value bars to start. So I'll have 4 minus 7x is equal to, you'll have negative x and then plus 4. Then you're going to have or. So let me write or. So then you're going to drop the absolute value bar. So 4 minus 7x is equal to negative x plus 4. And then you've got to pick one of these guys. Let's just do this one on the right this time. And you've got to wrap it in parentheses and just put a negative out in front. Let me slide this out of the way. We'll get to this later on. I'm just going to solve this one first, and then we'll slide down. So for this one, let's add x to both sides of the equation. And let's subtract 4 away from each side of the equation. So this is going to cancel, and this is going to cancel. So we can already see that x is going to be 0, but let's just continue. So this is going to cancel over here completely. So on the right, I just have 0. On the left, I have negative 7x plus x. That is going to give me negative 6x. Divide both sides by negative 6. And like I just said, x is going to be 0. So this cancels. And we'll put this over here, or I can just write it here. So x is equal to 0 divided by negative 6 is 0. So let me just write up here, x equals 0. We'll come back up to this. We'll add on to that solution in a moment. Okay, so let me start by just writing the left side. 4 minus 7x is equal to, on the right side, I'm going to apply this negative to each term inside the parentheses. So the negative of negative x is x, right? I'm just changing the sign from negative to positive, and this becomes negative. Right, again, just changing the sign. So from here, let's subtract x away from each side of the equation. So this is going to cancel. And then let's subtract 4 away from each side of the equation. So this guy right here is going to cancel. So negative 7x minus x would be negative 8x. And this is equal to negative 4 minus 4 would be negative 8. Let's divide both sides of the equation by negative 8. And this is going to give us that x is equal to positive 1. So let's put a comma here and just put a 1. So x can be equal to 0. Or also it could be 1. Okay, let's look at problem number 5. So this one's just a little bit more involved, but it goes back to the same concept that we looked at the first part of the video. And essentially you want to isolate the absolute value operation on one side and a single number on the other. So we have 8 minus 7 times the absolute value of 9x minus 2, and this is set equal to negative 6. So the first thing you would want to do here is subtract 8 away from each side. So let's go ahead and do that. And so this is going to cancel over here. And what you'll have is negative 7, and I'll put times the absolute value of 9x minus 2 is equal to, you have negative 6 minus 8, that's negative 14. Okay, so because this is multiplication here, you want to use division to undo it. Again, you're trying to isolate this guy right here. So since negative 7 is multiplying that, you're going to, again, just divide both sides by this negative 7 because it's multiplying. And so this guy right here is going to cancel, and you'll have your absolute value of 9x minus 2 isolated on the left-hand side. On the right-hand side, negative 14 divided by negative 7 is going to be positive 2. Okay, so now we have this set up into the absolute value operation on one side, a single number on the other. So hopefully you remember how to solve this. Essentially, you're going to drop the absolute value bars, and you're going to take this 9x minus 2 set it equal to 2. Then or, drop the absolute value bars, so 9x minus 2, set it equal to negative 2. So let's add 2 to both sides of the equation over here. This would cancel. You'll have 9x is equal to 4. Divide both sides of the equation by 9. You get x is equal to 4/9. Okay, then I'll put or. Over here, let's add 2 to both sides of the equation. This is going to cancel. We'll have 9x is equal to negative 2 plus 2 is 0. Divide both sides of the equation by 9. You're going to get x is equal to 0. Okay, so x could be 4/9 or x could be 0. Again, most people will just write this as x equals, let's put 0, 4/9. Okay, let's look at problem number 6, a similar setup to the last one. So what we're going to have here is 6 times the absolute value of 10x minus 1, then minus 4 is equal to 50. So again, I want to isolate the absolute value operation on one side, and I want a single number on the other. So let's deal with getting rid of this minus 4 here first. So let me add 4 to both sides of the equation. And so this would cancel. You'll have 6 times the absolute value of 10x minus 1 is equal to, this would be 54 here. And what I'm going to do is just divide both sides of the equation by 6, since 6 is multiplying this guy. So we'll cancel this with this. And now on the left-hand side, I have the absolute value of 10x minus 1 is equal to, on the right-hand side, 54 divided by 6 is going to be 9. So now that we have this in the format that we want to drop the absolute value bars. So I'll say 10x minus 1 and set it equal to 9. Then or, we want to drop the absolute value bar, so 10x minus 1, and set it equal to the negative of this number, so negative 9. So over here on the left, let's add 1 to both sides of the equation. You're going to get 10x is equal to 9 plus 1 is 10. Divide both sides by 10. And let me show this as canceling here. We'll get x is equal to 1. Then over here, let's add 1 to both sides of the equation. This would be 10x is equal to negative 9 plus 1 is going to be negative 8. Let's divide both sides of the equation by 10. Let's cancel this out. And I'll put my or here. I'll say that x is equal to, we know this is negative. Let's write 8 as 4 times 2. Let's write 10 as 5 times 2. And let's cancel this common factor of 2 between numerator and denominator. So x equals negative 4/5 like this. So these are our two solutions. X could be equal to, let's put negative 4/5, and then you could put comma, positive 1. Okay, let's look at problem number 7. So here we have 9 plus 2 times the absolute value of 3x plus 7, and this is set equal to negative 37. So what I want to do again is isolate this part right here on one side, have a single number on the other. So let's subtract 9 away from each side of the equation. Then let's cancel this. I'll have 2 times the absolute value of 3x plus 7 is equal to negative 37 plus negative 9 is going to be negative 46. And then from here, I can just divide both sides by 2, and this would cancel. And I'll have the absolute value of 3x plus 7 is equal to negative 46 divided by 2 would be negative 23. Now, I don't need to continue here because, as I told you in the lesson, if you have the absolute value operation isolated on one side and you have a negative number on the other, it's impossible for you to get a solution, right? Because the absolute value operation makes things non-negative. So there's no such value that I can plug in for x here, multiplied by 3 and add to 7. When I take the absolute value of whatever that number is, whatever I can come up with, it's always going to either be 0 or some positive value. It can never, ever, ever be a negative 23, right? So this is not possible. So there is no solution here, okay? And some people like to write the symbol for the null or empty set. Again, we'll talk about this later on in the course. But if you ever get something that sets up this way to where the right side here is negative, again, once you've isolated the absolute value operation, you're not going to have a solution. If the right side was 0, then you would just have one single equation to solve. Okay, let's look at problem number 8. And here we have 4 times the absolute value of negative 3 minus 8x, then plus 2, and this is equal to 118. Okay, so again, just trying to isolate this absolute value operation here. So I'm going to subtract 2 away from each side of the equation. And let's cancel this. We have 4 times the absolute value of negative 3 minus 8x like this. And this equals 118 minus 2 would be 116. Let's divide each side of the equation by 4. Let's slide down here. And let me cancel this guy with this guy. We have the absolute value of negative 3 minus 8x is equal to 116 divided by 4 would be 29. So again, once I get to this setup here, all I need to do is drop the absolute value bars. And I'm going to actually reorder this a little bit. I'm going to put negative 8x minus 3. And then I'll set this equal to positive 29. Then or I'll have negative 8x minus 3. I'll set this equal to negative 29. So I'm just going to solve these two equations, and let's see what we get. So let's add 3 to both sides of the equation over here. This would cancel. I'll have negative 8x is equal to 29 plus 3 is 32. And let's divide both sides of the equation by negative 8. We'll get x is equal to, this would be 32 divided by negative 8 is negative 4. Let me put or here. Over on this side, let's add 3 to both sides of the equation. Let's cancel this. If I do negative 29 plus 3, that's negative 26. So you're going to have negative 8x is equal to negative 26. Let's divide each side of the equation by negative 8. Let's show this is canceling here. We'll have x is equal to, let's write 26 as 13 times 2. Let's write 8 as 4 times 2. And so we're going to show this is canceling this 2 with this 2. So x would be 13/4 there. So let's put that like that. Or if you want, you can put x is equal to, let's go negative 4, comma 13/4. All right, let's look at problem number 9. So this one looks like it'll be a little bit tedious because of the fractions. We have negative 11 over 10, which is multiplied by, let me show that, multiplied by this absolute value of 3/2 x plus 5/2, then plus 4/5 is equal to negative 147 over 160. So I would start by clearing the denominators. So on the outside of the absolute value operation, and you think about the denominators out there, you have a 10, a 5, and 160. So you can just use 160 as your LCD. And so 160 times this guy right here, 160 divided by 10 is 16, and 16 times 11 is 176. Let me put negative 176 times the absolute value of, you have this 3/2 x plus 5/2. And then plus, if I go 160 divided by 5, that's 32, and 32 times 4 is 128. And this would be equal to, over here, this would be negative 147, because again, I'm multiplying by 160. Okay, so this is all set up. I don't have any fractions anywhere except for inside the absolute value bars, which we'll deal with later on. Let me slide down here. And again, my goal is just to isolate this for right now. So let's subtract 128 away from each side of the equation. And so this is going to cancel. And so what I'll have is negative 176 times the absolute value of 3/2 x, and then plus 5/2. And then that's canceled. So this equals, if I do negative 147 minus 128 in my calculator, I get negative 275. We have this negative 176 times the absolute value of 3/2 x plus 5/2. This is set equal to negative 275. So let's divide both sides of the equation by negative 176, like this. And so this is going to cancel. And we'll say that we have the absolute value of 3/2 x plus 5/2. And this is equal to, negative divided by negative is positive. So let's write 275. I'm actually going to write this as 5. I would start with 5 times 55, so it would be 5 times 5 times 11. And then for 176, I could do 16 times 11. So let me put 11 here times, you can put 16 or 2 to the 4th power if you want. It's really up to you. Let's just put 2 to the 4th power for right now. And we're going to cancel this common factor of 11. So this is going to be 25 over 16. So let's write that as 25 over 16. So from here, it's really not that bad. What I'm going to do is set what's inside of here equal to this, and then what's inside of here equal to the negative of this. So let's say that we have 3/2 x plus 5/2 is equal to 25 over 16. So for this equation, I can clear the fractions by multiplying everything by 16. So 16 divided by 2 is 8. So basically you would have 3x times 8, which is 24x. And then plus, again, 16 divided by 2 is 8. 8 times 5 is 40. And then this equals, obviously the denominator of 16 there would cancel. So this would set up the same for the next one. You would just go or, and this would be negative 25 instead of positive 25. Let me actually just erase this real quick. And then we'll say 24x plus 40 is equal to negative 25. And actually I should probably just do this over here so I can fit this all. So 24x plus 40 is equal to negative 25. All right, so now let's work on the one on the left. So let's subtract 40 away from each side of the equation. That's going to cancel. I'm going to have that 24x is equal to 25 minus 40 is going to be negative 15. And let's divide each side here by 24. And so I'm going to get x is equal to negative 15. Let's write that as 5 times 3. For 24, let's write that as 8 times 3. And we can see that we can cancel a common factor of 3 between numerator and denominator. So x here would be negative 5/8. So I'm actually just going to erase this and just put x equals negative 5/8 there. And then let me just drag this down here. So we have some room. I'll come back up and answer that completely in a minute. We know this is an OR. We can get rid of that. So let's put minus 40 on each side here. Cancel this. We'll have 24x is equal to negative 25 minus 40 would be negative 65. And let's divide both sides of the equation by 24. Let's cancel this. X is equal to, we know this is negative. 65 is 13 times 5. And 24 is basically 8 times 3, so 2 cubed times 3. So no common factors here other than 1. So we're going to have to write this as negative 65 over 24 like this. So let's erase this. Let's put our answer, let's put comma, and we'll put negative 65 over 24. All right, let's look at problem number 10. Again, another tedious one because we have some fractions involved. So we have negative 4/5 times the absolute value of 3/2 x minus 28/9. Then plus 8/5 is equal to 14 over 45. Okay, so thinking about the fractions on the outside of the absolute value bars, again, the LCD there, if you think about 5, 5, and 45, again, don't worry about what's inside the absolute value bars for right now. The LCD is going to be 45. So what I'm going to do is multiply both sides of the equation by 45. And so 45 divided by 5 would be 9. 9 times negative 4 is negative 36. So you'd have negative 36 times the absolute value of 3/2 x minus 28/9, and then plus, if I do 45 divided by 5, that's 9. 9 times 8 is 72. And this equals, obviously, if I multiply this by 45, the denominator would cancel, so you just have 14. Okay, let me slide down here. And now let me subtract 72 away from each side of the equation. Let's cancel this out. We'll have negative 36 over here on the left times the absolute value of, you have 3/2 x minus 28/9. And then this is equal to 14 minus 72 is negative 58. And then to finish this up, let's divide both sides of the equation by negative 36. And so this is going to cancel. And we'll have the absolute value of 3/2 x minus 28/9 is equal to, negative over negative is positive. For 58, it's 29 times 2. And then for 36, you can think about this as 6 times 6, and 6 is 3 times 2. So basically it's 2 squared, and then multiplied by 3 squared. So what I'm going to do is cancel one of these 2's. So I'll cancel one of those with this. And so this would be 29 over 3 squared is 9 times 2 would be 18. So 29 over 18 would be the simplified fraction there. Let's put this like this. So 29 over 18. Okay, so let's set up our equations. So again, what's inside the absolute value bars? So we have 3/2 x minus 28/9 is equal to 29 over 18. Let's clear the fractions first, and then I'll do the compound equation with OR. The LCD here would be 18. So if you multiply everything by 18, then 18 divided by 2 is 9. 9 times 3 is 27, so this is 27x. And then minus 18 divided by 9 is 2. 2 times 28 is 56. And this equals, obviously the 18 there would cancel, so you just have your 29. So let's erase this. And let's say OR. We'll take the 27x minus 56. Set this equal to now negative 29. Okay, so let's solve these two equations. Really not that bad. So we will add 56 to both sides of the equation. This would cancel. You'd have 27x is equal to 29 plus 56 would give me 85. And then I would divide both sides of the equation by 27. And so this is going to cancel. We'll have x is equal to, for 85, it's 17 times 5, and 27 is 3 cubed. So there's no common factors other than 1. So we just have to leave it in this format. Let me make the 5 a little bit better there. Now let me solve this one. I'm just going to get rid of this. We know it's an OR. Let me move this over here. And we'll come back up and list the solution in a moment. Let's add 56 to both sides of the equation. And let's get rid of this. We'll say 27x is equal to negative 29 plus 56 is 27. And then let's divide both sides of the equation by 27. Let me slide down here. And let's cancel this with this. We get x is equal to 1. And let's just put a comma here and put a 1 here. So x is equal to 85 over 27. And then also it could be 1.
All right, let's take a look at our practice test. We're told to solve each equation. For the first problem, we have 2 times the absolute value of x squared plus 8x minus 4. Then we have minus 5, and this is equal to 5. So the first thing we want to do when we have an absolute value equation in this form, we want to isolate the absolute value operation on one side and get a single number on the other. Now, on the other side where we have that single number, if we have a positive number, we're going to set up a compound equation with OR, and I'll explain more about that in a moment. If we have 0, then we have a single equation, and then if we have a negative, then we have no solution. Okay, so let's go through this. The first thing I would do here is add 5 to both sides of this equation. So we know this would cancel away. So this is 2 times the absolute value of x squared plus 8x, then minus 4. And this will be equal to 5 plus 5 is going to give me 10. Now, I still want to isolate this absolute value operation. So we have 2 that's multiplying it. So I'm just going to divide both sides of the equation by 2. So this is going to cancel here. And we'll have the absolute value of x squared, then plus 8x, then minus 4. And this will now be equal to 10 divided by 2 is going to be 5. Okay, so now that we have the absolute value operation isolated on one side and a positive number on the other, we're going to set up a compound equation with OR. The idea here is that I can find some value for x and plug it in such that this guy right here, this expression inside the absolute value bars, could be equal to 5, right? So it could be equal to this 5, or it could be equal to the negative of that. So negative 5, because the absolute value of negative 5 will get me to 5. And so either way, I'd have a true statement. So what we want to put up here is that x squared plus 8x minus 4, again, could be 5. Then or x squared plus 8x minus 4 could be negative 5. Because again, if I had a negative 5 inside of there, the absolute value of negative 5 would be 5. You would get 5 equals 5, so it would be a true statement either way. Okay, so let's solve both of these. So I'm going to start with this top guy here. So x squared plus 8x minus 4 is equal to 5. I'm just going to put this in standard form and see if I can factor it. So I'm going to subtract 5 away from each side of the equation. This cancels and becomes 0. So we'll say this is x squared and then plus 8x. Negative 4 minus 5 is going to be negative 9. And this equals 0. Okay, can I factor this? Can I find two integers such that the sum is 8 and the product is negative 9? Well, yeah, of course I can. Let's put an x here and an x here. Set this equal to 0 over here. And those two integers that I'm looking for, it's going to be a positive 9 and a negative 1. So I want plus 9 here and minus 1 here. So now to get a solution, I could just say x plus 9 is equal to 0. Then or x minus 1 is equal to 0. Let's subtract 9 away from each side of the equation over here. We'll say x is equal to negative 9. And then we can add 1 to both sides over here. This will be our x equals 1. Okay, so those are two solutions, but we're going to end up with 4 solutions. Okay, so this is just the first part. So let's grab this answer here. Okay, so now we have to work on the other equation. So for this one, we have the x squared plus 8x minus 4 is equal to negative 5. Now this is not one you can solve by factoring. So let's add 5 to both sides of the equation. We'll cancel this and put 0. This is x squared and then plus 8x, and then negative 4 plus 5, that's going to be positive 1, and this equals 0. So what we'll have to do here is use the quadratic formula. So let's say that this is going to be a, this is going to be b, and this is going to be c. So you have x is equal to the negative of b. So b is 8, so the negative of 8, then plus or minus the square root of, you have b squared. So 8 squared is 64, then minus 4 times a is 1, then times c is also 1, and this is over your 2 times a, and a is 1. Okay, so let's say x is equal to, you have negative 8, then plus or minus the square root of, for this one, 4 times 1 is just 4, and 64 minus 4 is 60. So this is 60, or if you want to simplify this, you might as well just write this as 15 times 4 like this, and this will be over. 2 times 1 is just 2. Now, without going to a different line, we know that the square root of 4 is 2, right? So I can say this is 2 times the square root of 15, right? 15 is just 5 times 3, so nothing else is going to simplify. So we'll say x is equal to, I'll pull out my 2, and I'll have negative 4, then plus or minus the square root of 15, and this would be over 2, and I'm just going to cancel this 2 with this 2. And so what we'll have is x is equal to negative 4, then plus or minus the square root of 15. So coming back up here, I'll just throw these in the mix. I'll put negative 4, and then plus or minus the square root of 15. Now again, you can always pause the video and check this on your own. I've already checked this, so I know it works. But essentially, you have for x, it could be negative 9, it could be positive 1, it could be negative 4, plus the square root of 15, or then you could have negative 4 minus the square root of 15. Okay, let's take a look at problem 2 now. So we have negative 2 times the absolute value of 2x squared minus 7x plus 5, then plus 3, and this equals negative 7. Now, don't assume because this is negative over here that there's no solution. Remember, that's only going to occur if you have something like the absolute value of, let's just say u is equal to some negative number. Let's just say it's negative 7. Well, in this case, you can't get a solution, right? Because this is isolated over here, and the absolute value of some number is either going to be 0 or some positive number, so it can't be negative. But we're not isolated in terms of this absolute value operation yet, so we can't make that determination. So we're going to first subtract 3 away from each side of the equation. We'll cancel that away. We'll say negative 2 times the absolute value of 2x squared, then minus 7x, then plus 5. We'll say this is equal to negative 7 minus 3 is negative 10. And then again, I'm going to divide both sides of the equation by negative 2 just to get rid of this negative 2 over here. So let's cancel this with this. And this will give me the absolute value of 2x squared minus 7x plus 5 is equal to negative 10 divided by negative 2 is positive 5. We're going to take this expression inside the absolute value bars, and we're going to set it equal to 5. Then we're going to say or. We're going to take this expression again inside the absolute value bars, and we're going to set it equal to negative 5. So we're going to say 2x squared minus 7x plus 5 could be 5, right? So if this guy inside of here was 5, you get the absolute value of 5, which equals 5. That would be a true statement. Then or, it could be 2x squared minus 7x plus 5. It could be negative 5. So if I plug something in for x, and that gives me negative 5 over here inside the absolute value bars, when I take the absolute value of negative 5, I get 5, right? So that's why I need these two equations. Let's start on the top one. So we have 2x squared minus 7x plus 5 is equal to 5. And of course, if you have 5 on each side of an equation, you could just get rid of it. So I can just say that this would cancel away, and this would be 0. So let's say we have 2x squared minus 7x is equal to 0 now. And I can solve this pretty quickly using factoring. I could just pull out an x, and that would give me 2x minus 7 inside. And so for this one, you can basically say that x is equal to 0, or it's going to be that 2x minus 7 is equal to 0. Add 7 to both sides, cancel this away. You get 2x is equal to 7, divide both sides by 2, and you get x is 7 halves. So let's put that there. So coming back up here, I just put x is 0 and then 7 halves. But we also have to solve the other part of this. So coming back, I need to work on this one now. So here I would add 5 to both sides to put this in standard form. So I get 2x squared minus 7x and then plus 10 is equal to 0. Now, just to save some time, I'm just going to tell you this is not going to factor. So we need to use the quadratic formula. So this is A. This is B. Remember, you can go plus negative if that's confusing for you. And this is C. So we would have x is equal to the negative of B. Now here, B is negative 7. So you have the negative of negative 7. We'll change that into positive 7 in a moment. I just want to write it out. Then plus or minus the square root of, you have B squared. So negative 7, that's being squared. So again, wrap this in parentheses. I'll show it all so that nobody's lost. Then you have minus 4 times A is 2, times C is 10. Okay, then this is over 2 times A is 2, so let's put 2 times 2. Okay, let's see what we can do. So we get x is equal to, again, the negative of negative 7 is positive 7, then plus or minus the square root of. Negative 7 being squared is going to be 49. Then you know you have minus here, and then 4 times 2 is 8. 8 times 10 is 80. 49 minus 80 is negative 31. So let me erase this and put negative 31. And we'll simplify that using the imaginary unit in a moment. So this is over 2 times 2, which is going to be 4. And I'm going to say this is x is equal to 7 plus or minus I times the square root of 31. And this will be over 4. So this is as simple as we can make this. So coming back up here, we'll just put our solution together. So I'll just erase this and put a comma here. And I'll just drag this over. So we have 4 solutions. So x could be 0. It could be 7 halves, or then 7 plus I times square root of 31 over 4, or then also 7 minus I times square root of 31 over 4. All right, let's take a look at problem number 3 now. So we have 1/2 times the absolute value of 3x squared minus 14x minus 1, then plus 1, and this equals 41 over 2. So again, my goal is to isolate this absolute value operation on one side and then have a number on the other. So in this particular case, you see you have some fractions involved. You have this 1/2 here. You have 41/2. If I multiply everything here by 2, those fractions are going to go away. So 1/2 times 2 would be 1. So this would be 1 times the absolute value of 3x squared minus 14x minus 1. And then you'd have plus, again, I'm multiplying everything by 2. So 1 times 2 would be 2. And this equals 41/2 times 2 would be 41. So again, I just multiplied everything by 2. Now, to isolate the absolute value operation, in this case, we would just subtract 2 away from each side of the equation. This would cancel. Then you would have the absolute value of 3x squared minus 14x minus 1. And this equals 41 minus 2 is going to be 39. Okay, so once again, once we have it set up to where you have the absolute value operation isolated on one side, and in this case, some positive number on the other, you're going to set up a compound equation with OR. So we're going to say that this is 3x squared minus 14x minus 1 is equal to 39. Then OR, we have 3x squared minus 14x minus 1 is equal to, again, it could be negative 39. So once again, the reasoning for this, if I plug something in for x and the result of what's inside the absolute value bar is just 39, then the absolute value of 39 would be 39. So that's a true statement. Additionally, we could plug something in for x and then we get negative 39 inside the absolute value bars. You take the absolute value of negative 39 and you get positive 39 as well. So that's why you need these two equations. Okay, let's start with the top one. So we have 3x squared minus 14x minus 1 is equal to 39. So the first thing I'm going to do is subtract 39 away from each side of the equation. This would cancel and become 0. We'll have 3x squared, then minus 14x, and then negative 1 minus 39 is negative 40, and this equals 0. Now, can we factor this? Again, this is a tougher scenario, so if you think the quadratic formula would be faster here, you could use that. So let's go ahead and set this up and see what happens. I'm going to put a 3x here and an x here. Now, I want to think about the fact that this is a minus here, so I know I'm going to be subtracting. And in terms of absolute value, I want to get to 14. Forget about the fact that it's negative. So think about 40. You've got 1 and 40. That's just too big. It's not going to work. You've got 2 and 20. That's, let's see, if you put a 2 here and a 20 here, would that work? Looks like it would. So this right here would be 6x, and this would be 20x. So 20x minus 6x would give me 14x. I want negative 14x. So that means I want to make this guy negative and this guy positive, right? So that this is a plus 6x and this is a minus 20x. So 6x minus 20x would give me negative 14x. So that's what I'm looking for. Okay, so we would say that we have 3x minus 20 is equal to 0. And then or we have x plus 2 is equal to 0. For this one, let's add 20 to both sides of the equation. We'll cancel this. We get 3x is equal to 20. Divide both sides of the equation by 3. This cancels. We'll say that x is equal to 20 over 3. Let me actually erase all of this so we can fit everything on one line. And then for this one, we already know that we would simply subtract 2 away from each side of the equation. So x could also be negative 2. So let's put x equals 20 over 3 or negative 2. All right, the next thing I would look at is this other equation. So here I would add 39 to both sides. Let's cancel this and put 0. So we have 3x squared, then minus 14x, and then negative 1 plus 39 is going to be plus 38. And of course, this equals 0. Now, what I want to do from here, I'm not going to be able to factor this. I'm just going to say that this is A. I'll go plus negative here, so this is B, and then this is C. So this is going to be something that's very big in terms of the solution, so I would recommend using a calculator. So I'll say x is equal to the negative of B. So B is negative 14, so the negative of negative 14 is positive 14. Then plus or minus the square root of, you have B squared. So negative 14 squared, that's going to be 196, then minus 4 times A, which is 3, times C, which is 38. So let's just do this now. 4 times 3 is 12. 12 times 38, that's going to be 456. So if we did 196 minus 456, you're going to get negative 260. So negative 260. And let's think about simplifying that in a moment. Let's put this over. 2 times A is 3, so 2 times 3 is 6. So for 260, I could say, let me first put this as negative 1 and then times 260 divided by 4 is 65. So I could say times 4
and then times. For 65, it's 5 times 13. So you could pull out the square root of -1, that's going to be I. You could also pull out the square root of 4, that's going to be 2. So let's say this is x is equal to 14 plus or minus, again, this is going to be 2i times the square root of 5 times 13 would get you back to 65, and this is over 6. Now, I think we can all see that we can simplify this further by factoring out a 2 from the numerator and canceling with the denominator. So let's say x is equal to, I'll pull out my 2, I'll have 7 plus or minus your I times square root of 65. Then this will be over. We'll say 2 times 3 like this. And then let's cancel this 2 with this 2. And we'll say that x is equal to 7 plus or minus I times square root of 65 over 3. So coming back up here, I'm just going to add this into my list here. So in other words, I have x is equal to 20 over 3, negative 2, and then 7 plus I times square root of 65 over 3. Let's make this 3 a little bit better here. And then also 7 minus I times square root of 65 over 3. All right, let's take a look at problem number 4 now. So we have the absolute value of 6x squared minus 7x plus 13 is equal to the absolute value of 4x squared minus 4x plus 12. Okay, so if you have something like this, let's say the absolute value of, let's say some expression u is equal to, let's say the absolute value of some expression w, then what's going to happen is you have two scenarios. So the first one is you could just set u equal to w. So I call this just dropping the absolute value bars. So u could be equal to w. And then the other scenario is going to be that these guys are going to be negatives of each other. So you could say, or u is equal to the negative of w, or basically you could say negative u is equal to w, whatever you want to do. So I am always going to choose the rightmost guy and make that into its opposite, but you could use the leftmost guy. Again, it's just personal preference. So for the first scenario, I'm just going to drop the absolute value bars. I'm just going to say 6x squared minus 7x plus 13 is equal to 4x squared minus 4x plus 12. So just drop the absolute value bars. That's the first one. Then you're going to say or. For the second one, drop your absolute value bars. So we're just going to copy this. So 6x squared minus 7x plus 13 is equal to 4x squared minus 4x plus 12. Now you have to pick one of these and transform it into its opposite. Okay, so how we do that is we're going to wrap this with parentheses and just put a negative out in front. Okay, that negative is going to get distributed to each term. Now, you could have left this one as is and wrapped this one with parentheses and put a negative out in front, but my preference is just to do the one on the right. If you want to do the one on the left, it's just up to you. Okay, let's start with this guy on the top. So we have 6x squared minus 7x plus 13 is equal to 4x squared minus 4x plus 12. What I'll do here is just subtract 4x squared away from each side of the equation. This will cancel. I'm going to add 4x to both sides of the equation. This will cancel. And I'm going to subtract 12 away from each side of the equation. So this is canceling and we have 0. Okay, 6x squared minus 4x squared is 2x squared. Negative 7x plus 4x is going to be minus 3x. And then 13 minus 12 is 1. So plus 1, and this equals 0. Now, can we solve this using factoring? Would be really easy to check. So let's go through this really quickly. For 2, it's a prime number. So it would be 2x here and x here. This is a minus and this is a plus. So it has to be a negative and a negative. And for 1, it's only 1 times 1. So it would have to be this that would work. There's no other possibility. So this right here would be negative 2x, and this would be negative x, and negative 2x plus negative x is negative 3x. So this does in fact work. Okay, so we have 2x minus 1 is equal to 0, or x minus 1 is equal to 0. Let's add 1 to both sides of the equation. Let's cancel this. We have 2x is equal to 1. Divide both sides by 2. Let's cancel this away. So x could be 1/2. Let me actually get rid of all this. Write this more cleanly. We'll move this over. Then or, here you would just add 1 to both sides. So x could also be 1. So coming back up here, this is the first part. So x could be 1/2 and then also 1. But again, we have to solve that other guy. So coming back, we'll distribute this negative to each term. Let me just copy this. So this is 6x squared minus 7x plus 13 is equal to, you would have negative 4x squared, then plus 4x, and then minus 12. So let's add 4x squared to both sides of our equation. This cancels. Let's subtract 4x from both sides. This cancels. Let's add 12 to both sides. So this cancels. So this is 0 over here. On the left here, 6x squared plus 4x squared is 10x squared.
Then negative 7x minus 4x is minus 11x. And then 13 plus 12 is going to be 25, and this equals 0. So I'm going to tell you in advance this is not going to factor, just so we don't waste time. So this would be our A, this would be our B. Again, you can go plus negative, and this would be our C. All right, so for the quadratic formula, we have x is equal to the negative of negative 11. So the negative of B, the negative of negative 11 is 11. Then plus or minus the square root of B squared. So negative 11 being squared is 121. Then minus 4 times A is 10, times C is 25. This is all over 2 times A is 10, so this is 20. So here I would do 4 times 25 first, because that's easy to do, it's 100, and then 100 times 10 is 1,000. So this right here is 1,000, and if you go 121 minus 1,000, that's negative 879. So negative 879. All right, so to simplify, let's go x is equal to 11 plus or minus. This negative here can come out. The square root of negative 1 is going to be I, and then times the square root of 879. Now, in case you're wondering if you could simplify this, 8 plus 7 is 15. 15 plus 9 is going to be 24. Now, 24 is divisible by 3, so that means 879 will be. If you punch that into your calculator, 879 divided by 3, you're going to get 293, and unfortunately, 293 is a prime number, so that's as far as we can go, right? So we just write it this way. So this is over your 20 here. There's nothing else we can do. So just coming back up, let me get rid of this and put a comma here. We have our 4 solutions. So we have x is a half, then or x is 1, then or x is 11 plus I times square root of 879 over 20, and then also x would be 11 minus I times square root of 879 over 20. All right, let's take a look at problem number 5 now. So we have the absolute value of 3x squared minus 8 is equal to the absolute value of x minus 2. And the idea here is that in the first scenario, we're just going to drop the absolute value bars. So we're going to have 3x squared minus 8 is equal to x minus 2. Then I'll say or. In the second scenario, you're going to drop the absolute value bars. So 3x squared minus 8 is equal to x minus 2. But then I'm going to pick one of these guys. It doesn't matter which one. I typically use the one on the right. You're going to wrap it and put a negative out in front. So you're making it into its opposite. So let's grab this guy. So for this guy on the left, I'm just going to put it in standard form. I'm going to subtract x away from each side. So let's put that maybe over here. And then I'm going to add 2 to both sides. So let's put that over there. This will cancel, and this will cancel, and this will be 0. So 3x squared, then minus x, those are not going to combine, obviously. And then negative 8 plus 2 is going to be negative 6, and this equals 0. Okay, can we solve this with factoring? This would be a negative 1 here. So let's see. I could put a 3x here, and then I could put an x here. Well, I would need to make the outer and the inner combine to this negative 1. For 6, it's either 1 times 6 or it's 2 times 3. So if I have 1 times 6, the 6 can't go here because it have a common factor of 3. So it would have to go here, and that's going to be too big. So that's out. So it would have to be 2 and 3. The 3 can't go here, but it could go here, and the 2 could go here. So this would be 9 minus 2, which is 7. So this is not something you can factor. Okay, so let's use the quadratic formula. So we'll say this is A. We'll say this is B. And we'll say this is C. So we'll say that this is x is equal to the negative of B. So the negative of negative 1 plus or minus the square root of B squared. So B is negative 1, so negative 1 squared. Then minus 4 times A is 3, times C is negative 6. This is all over 2A, and A is 3. So 2 times 3, let's just write it out. Let's simplify. So x is equal to the negative of negative 1 is 1, then plus or minus the square root of negative 1 squared is 1. Then basically you're going to have a negative times another negative, which is positive. So just put plus now. Forget about the signs. So 4 times 3 is 12, and 12 times 6, that's going to be 72. And 72 plus 1 is going to be 73. So this would be the square root of 73. Then this is over. 2 times 3 is going to be 6. So this would be our solution. You can't really do anything with the square root of 73 because 73 is a prime number. So I'm just going to come back up here and place that there, and then we'll go back down. Let's say this is 3x squared and then minus 8. I'm going to distribute this. So let's say it's equal to negative x and then plus 2. Then I'm going to add x to both sides. I was thinking I could squeeze it in there, but maybe I can't. Then subtract 2 away from each side. So let's cancel this and say it's 0.
So you'll have 3x squared, then plus x, and then negative 8 minus 2 is negative 10, and this equals 0. So can we factor this guy? Well, yeah, I could put a 3x here and an x here. And this guy is a minus here, so I know I want to subtract. In terms of absolute value, I want to get to 1, okay? So if I think about 10, it's 1 and 10, which is just too big to work, or it's 2 and 5. Now, if you put the 5 here, it's too big, but if you put the 5 here and the 2 here, then that's going to give me 6x and then 5x, and so I just need to make this a plus and this a minus. So this is plus 6x and this is minus 5x. 6x minus 5x would give me x, or 1x, and so this is what we want. So I would set 3x minus 5 equal to 0, add 5 to both sides of the equation. This cancels. You'll get 3x is equal to 5. Divide both sides by 3, and you get x is equal to 5/3. The other guy will say x plus 2 is equal to 0. Subtract 2 away from each side. We would also get x is equal to negative 2. So coming back, I'll just put a comma here. So you have these 4 solutions. So x could be 1 plus the square root of 73 over 6, 1 minus the square root of 73 over 6, 5/3, or also negative 2. All right, let's take a look at problem number 6 now. So we have the absolute value of 2x minus 1 over x minus 5, and this equals 4. Just remember, if you're working on this, you need to make sure you're not dividing by 0. So you can take note of the domain before you start, or you can deal with it later. It's really up to you. But just make sure that you're not dividing by 0. That's very important. So the setup here is basically the same. You would just drop the absolute value bar. So 2x minus 1 over x minus 5 is equal to 4. Then say or. You're going to drop the bars and say 2x minus 1 over x minus 5 is equal to. Now you're going to switch this to its opposite, so negative 4. Again, the reason we do this, if you find something for x that makes this guy 4, well, then the absolute value of 4 is 4, so that works. Then if you find something for x that makes this guy negative 4, then the absolute value of negative 4 is also 4, so that works as well. So that's why you need these two different equations. And I'll start with the one on the left. So let's go 2x minus 1 over x minus 5 is equal to 4. I'm just going to clear the denominator. So I'm going to multiply both sides by this quantity x minus 5. So let's see what that gives us. So over here, this is going to cancel. You'll get 2x minus 1 is equal to, basically 4 times x is 4x, and then minus 4 times 5 would be 20. From here, I'm going to subtract 4x away from each side of the equation. This would cancel. I'm going to add 1 to both sides of the equation. So then this would cancel. So 2x minus 4x is going to be negative 2x, and this equals negative 20 plus 1 is going to be negative 19. Let's divide both sides of the equation by negative 2. This would cancel, and you're going to get that x is equal to 19 over 2. Okay, coming back up here, I'll just drop this one in here and put a comma. We'll go back down. Okay, so let's solve this other guy here. So I want to multiply by x minus 5 over here, and then also by x minus 5 over here. Again, that's just going to clear the denominator. Let me wrap that, and I'll show this as canceling. So you're going to get 2x minus 1 is equal to negative 4 times x is negative 4x. And then negative 4 times negative 5 is plus 20. Then we can add 4x to both sides of our equation and add 1 to both sides of our equation. So we'll say that this is going to cancel and this is going to cancel. So 2x plus 4x is 6x, and this equals 20 plus 1 is 21. We'll divide both sides of the equation by 6. And then we're going to cancel this with this. We'll say x is equal to, for 21, I'm going to factor that as 7 times 3. Let's make that 3 a little bit more legible. And then for 6, I'm going to factor that as 2 times 3. And so I'm going to cancel this 3 with this 3. And so x here is going to be 7/2. So that's my other solution. So coming back up here, we could just write this in and say it could also be 7/2. You can get rid of this and make that 2 better. Now, again, this is the point where you would want to check. With a rational expression, remember, you can't divide by 0. I mentioned that earlier. So here, you just want to make sure that x is not 5, right? Because 5 minus 5 would be 0. You get an answer of 19/2, and you get an answer of 7/2. So you're good to go there as long as you didn't make a mistake, right? It's always good to plug things in and check to make sure you didn't make a silly mistake. I've already checked these. You're going to get 4 in each case on the left, and then is equal to 4 on the right. So it's a true statement for each one of these. All right, let's take a look at problem number 7 now. So we have the absolute value of 9x minus 5 over 3x minus 1. And this is equal to 2. So again, for the first scenario, I'm just going to drop the absolute value bars. So we'll have 9x minus 5 over 3x minus 1. And this will be equal to 2. Then I'm going to go or.
In the second scenario, we'll drop the absolute value bars. So 9x minus 5. This is over 3x minus 1. We'll set this equal to, again, the opposite of this, which is just negative 2. Okay, the guy on the left, I'll start with that. So 9x minus 5 over 3x minus 1 is equal to 2. I'm going to multiply both sides by 3x minus 1 so that I can cancel this denominator here. So let me do that over here as well. And so you'll have 9x minus 5 on the left is equal to, on the right, 2 times 3x is 6x. And then minus 2 times 1 is 2. Okay, from here I'm going to subtract 6x away from each side. And this will cancel. I'm going to add 5 to both sides. So this will cancel. 9x minus 6x is 3x. And this equals negative 2 plus 5 is going to be 3. Divide both sides by 3. This cancels. You get x is equal to 1. So coming back up here, I'm just going to put x equals 1. I'll put a comma. All right, now we have to solve the other part. So we have 9x minus 5 over 3x minus 1. This equals negative 2. Again, I'm just going to clear the denominator. So I'm going to multiply both sides by 3x minus 1. So I'll multiply over here by 3x minus 1. So this is going to cancel with this. And so you're going to have 9x minus 5 is equal to negative 2 times 3x is negative 6x. Negative 2 times negative 1 is positive 2. I will add 6x to both sides of the equation. This will cancel. And I'm going to add 5 to both sides of the equation. So this will cancel. 9x plus 6x is 15x. And this equals 2 plus 5 is 7. Divide both sides by 15. This would cancel. And you get x is equal to 7 over 15. Okay, so coming back up here, let me just get rid of this. I'll just slide this in here. So x could be 1 or 7 over 15. Again, I'm going to let you check this on your own. If you plug in a 1 or if you plug in a 7 over 15 for x, then you're going to see that the left side is 2 in each case. Now, if you're checking this again and you're on a test and you want to go through this quickly, well, you just want to make sure that this denominator is not made 0 by any of these guys. So you just say that 3x minus 1 is equal to 0, add 1 to both sides. So 3x here would be equal to 1, divide both sides by 3. So x is not going to be able to be equal to 1/3. Okay, here you have 1 and 7 over 15. So we're not violating our domain, right? So we're okay as long as we didn't make a mistake. And again, I've already checked these, so they both work. Okay, let's look at problem number 8 now. So we have the absolute value of 10 over x minus 1 is equal to the absolute value of 5 over x plus 3. So again, all you have to do is in the first case, drop the absolute value bars. So 10 over x minus 1 is equal to 5 over x plus 3. Then or, again, drop the absolute value bars. So 10 over x minus 1 is equal to 5 over x plus 3. Now you've got to make one of these, either this one on the left or this one on the right, into its opposite. And the way you do this with a rational expression, you basically pick either the numerator or the denominator and you make it into its negative. So I can say that this is negative 5 here like this, or if I wanted to, I could put the negative down here and wrap this. I think that's more complicated, so I won't do that. You could also just put the negative out in front, but that's going to be a little bit confusing when you go to cross multiply. So I like to just put it in the numerator if it's simple like this. Okay, so thinking about what we have here, let's just start with the guy on the left. And I'm just going to drag this down just a little bit, and we can just cross multiply. And so what we'll have is 10 times the quantity x plus 3 is equal to 5 times the quantity x minus 1. Now, before you distribute, you could just divide both sides of the equation by 5. So this would cancel, and this would be 2. Right? So this is a little bit easier because now you just have 2 times x, which is 2x, and then plus 2 times 3, which is 6. Over here, this would just be x minus 1. So this becomes a breeze to solve. We just subtract x away from each side. This cancels. Subtract 6 away from each side. This cancels. 2x minus x is going to be x. And this equals negative 1 minus 6 is negative 7. So x equals negative 7. So let's put a comma there. All right, let's come to this other guy here and see if we can get a solution. Again, I'm just going to cross multiply. So we're going to multiply this way and this way. So we'll have 10 times the quantity x plus 3. And this will be equal to negative 5 times the quantity x minus 1. So again, you could distribute everything first if you wanted to, but I think it's easier just to divide both sides by, you could do negative 5 or positive 5. Let's just do 5, I think. That might make it easier. So we'll just divide both sides by 5. So this will be 2. So this is 2x plus 6 is equal to, negative 5 divided by 5 would be negative 1. So don't forget about that negative 1 there. So negative 1 times x is negative x, and then negative 1 times negative 1 is positive 1. So from here, let's add x to both sides of the equation. Let's subtract 6 away from each side of the equation. This will cancel. This will cancel.
So we have 2x plus x, which is 3x, is equal to 1 minus 6 is negative 5. Let's divide both sides of the equation by 3. That will cancel. We'll say x is equal to negative 5/3. Okay, so coming back up here, let's bring this in here. I'll just get rid of this and then slide this in here. And let's maybe make the 3 a little bit better there. So x here could be negative 7 or negative 5/3. Again, you want to first make sure you didn't violate the domain. Here, x can't be 1, and here, x can't be negative 3, right? So we know that. Additionally, you could plug in and check, make sure the left and the right sides are equal. Again, to not increase the length of the video, I've already done this. I'm just going to tell you that it does work, but you can always pause the video and see for yourself. All right, let's take a look at problem number 9. So we have the absolute value of 1 over 2x minus 5 is equal to the absolute value of 3 over x minus 7. So for the first case, I'm just going to remove the absolute value bars. So 1 over 2x minus 5. This is equal to 3 over x minus 7. Then or. For the second guy, remove the absolute value bar. So 1 over 2x minus 5 is equal to 3 over x minus 7. Then pick one of these guys and make it into its opposite. So because this is a rational expression, you can either put it up here if you want, or you can put it down here, but you have to wrap this with parentheses. Okay, so I think it's less complicated to just put it up here and be done with it. So let me grab this, bring this over here. Now let's just solve these both together. So I'm going to cross multiply in each case. So this is 3 times the quantity 2x minus 5 is equal to x minus 7 times 1 is just x minus 7. Let me just write or. I'm going to cross multiply here. So negative 3 times the quantity 2x minus 5 is equal to, again, 1 times x minus 7 is just going to be x minus 7. Now, before I go any further, I just want to note that the domain is going to be, let me write this out, and I'm going to erase it in a second, but just so you can see it. So the domain is the set of all x such that x is not equal to, well, we know that x can't be 7. Right? If you set x minus 7 equal to 0 and you solve, you get x is equal to 7. So it can't be 7. But this one right here, this 2x minus 5, you actually need to do some work for that. So you would have to say 2x minus 5 is equal to 0, add 5 to both sides. We'll cancel that and say 2x is equal to 5, divide both sides by 2. So x can't be 5 halves. Okay, so that's very important. Again, when you solve these types of problems, you want to know that x can't be 7 or 5 halves. That way, if you get that as a result, you can reject it. Okay, I'm going to erase this. You can write it down for your notes if you need it. And I'm actually going to erase this too. We don't need this anymore. From here, I'm going to distribute. So 3 times 2x is 6x, and then minus 3 times 5 is 15. And this equals x minus 7. I'm just going to keep going. So negative 3 times 2x would be negative 6x. And then negative 3 times negative 5 would be plus 15. And this equals x minus 7. Let's make that a minus there. Let me make this a little bit better here. So on this side, let's add 15 to both sides. And let's subtract x away from each side. So this is going to cancel, and this right here would cancel. 6x minus x would be 5x. And this equals negative 7 plus 15 is going to be 8. Divide both sides by 5. We'll cancel this. And you get x is equal to 8/5. So I'm actually just going to erase all of this scratch work. I'm going to get rid of this and just solve this real quick. And I'll put a comma here. Okay, so let's subtract 15 away from each side. That cancels. And let's subtract x away from each side. That cancels. So we have negative 6x minus x, and that's going to be negative 7x. And this equals negative 7 minus 15. That's going to be negative 22. So let's divide both sides of the equation by negative 7. That cancels. And you get x is equal to 22 over 7. We'll drag this over here. We'll grab this, and we'll just paste this right here. Again, you can pause the video and check and make sure the left and the right sides are equal. I've already done that. So no 8/5 is going to work, and so is 22 over 7. Again, for a quicker check, you just make sure you don't violate the domain. Again, we said that x couldn't be 7 and x couldn't be 5 halves. All right, let's take a look at problem number 10. So we're going to have the absolute value of 1 over x squared minus 7x plus 10 is equal to the absolute value of x over x minus 5. So for the first scenario, let's just drop the absolute value bars. So I'm going to say this is 1 over, and I'm just going to factor this. This is going to factor into x minus 5, this quantity, times the quantity x minus 2. And we'll say this is equal to, over here, this is x over x minus 5. And then I'll put or. For the other guy, remember, you just drop the absolute value bars. So we'll go 1 over, again, factoring this guy, it's x minus 5, that quantity, times the quantity x minus 2. And this equals, you have your x over x minus 5. And what you're going to do is make one of these guys into its opposite, or you could say it's negative. So I'm just going to put the negative up here. That's all you really need to do. Let me extend this just a little bit, and let's grab this, and let's come down here. These are pretty easy equations to solve. You can still cross multiply. So basically, I'm going to multiply like this and like this. Just be careful because your solution cannot be 5 or 2, right? Just looking at the denominators involved, right? You can write out your domain statement if you want. I think we don't need that at this point. So I'm just going to say that this is going to be x times the quantity x minus 5 times the quantity x minus 2, and this would be equal to x minus 5. Okay, and we'll talk about how to solve this in a second. I just want to move this over and say or. I'm going to do the same thing over here. So this would be negative x times the quantity x minus 5 times the quantity x minus 2 is equal to, over here, this would be x minus 5. What we're going to do is actually divide everything here by x minus 5. And this is going to work out quite nicely. So this right here is going to be 1. And then over here, this would cancel. So you have x times the quantity x minus 2 is equal to 1. Okay, let me put or here. We'll just keep going. On this side, I'll divide both sides of the equation by x minus 5. And again, it's just going to be the same thing. So this is going to cancel. And this is going to be a big fat 1. So this would be negative x times the quantity x minus 2. And this will be equal to 1. Okay, so at this point, I'm just going to work on the one on the left, and then I'll come back and work on the one on the right. So here I'm going to distribute. So x times x is x squared. Then minus x times 2 is 2x. And then I'm going to subtract 1 away from each side. So this is minus 1, and this equals 0. Now, this is not something you can factor. There's no way to find two integers such that the sum is negative 2 and the product is negative 1. That's not going to happen. So what you would do here, just use your quadratic formula. Let's say this is A. Let's say we'll go plus negative here. This is B. Let's go plus negative here. This is going to be C. Okay, so we plug into our quadratic formula. So x is equal to the negative of B. So the negative of negative 2 is 2. Then plus or minus the square root of your B squared. So negative 2 being squared is 4. Then minus 4 times A is 1. Then times C is negative 1. So here you could just think about this as negative times negative is positive. So basically you would have 4 times 1 times 1, which is 4. So this would end up being 4 plus 4, or 8. Now we know that the square root of 8 is going to be 2 times square root of 2, right? So this would simplify to 2 times square root of 2. Then this is over 2a, and a is 1, so 2 times 1 is 2. Now, what I can do is make this a little bit simpler by factoring out a 2 from the numerator. So we'll say this is 2 out here, and this is 1 plus or minus the square root of 2 in here, and this is over 2. And I'm just going to cancel this with this, and let's say that x is equal to 1 plus or minus the square root of 2. Okay, so that's all we have. And coming back up, I'll just drop this one in here and put a comma. So coming back, we'll just work on this one now. So negative x times x is negative x squared. Then negative x times negative 2. That's going to give me plus 2x. And then if we subtract 1 away from each side, this is minus 1, and it equals 0. I would multiply everything here by negative 1. So it's just going to change the sign of everything. So this is x squared, then minus 2x, then plus 1, and this still equals 0. Okay, so I just multiplied everything by negative 1. At this point, I can just get rid of all this. We don't need this anymore. And I'm just going to think about factoring this guy, which is something you can do, because if you want two integers whose sum is negative 2 and whose product is positive 1, well, that's going to be x minus 1 times x minus 1, right? Or you could say it's x minus 1 quantity squared. I think writing it this way makes it more easy to determine that your solution is x equals 1, but again, whatever you have to do. So if we come back up, we would also say a 1 there. Okay, so one solution would be x is 1 plus the square root of 2. Another would be 1 minus the square root of 2. And then your final solution would be 1. Again, just make sure if you're checking this very quickly that you're not violating the domain. Remember, we factored this into the quantity x minus 5 times the quantity x minus 2. So x can't be 5 and x can't be 2. So nothing here is going to violate that. Again, if you want to do a full check, then plug in for each x. Make sure the left and the right sides are equal. I've already done that here, and I can confirm that these three solutions are correct. All right, let's take a look at our practice test. We're told to solve each equation, and for the first problem, we're going to have an absolute value operation that's nested inside of another absolute value operation. So here you have the absolute value of, and then you have the absolute value of 2x minus 1, then minus 3, and this equals 12. So how are we going to solve something like this? Well, I want you to recall the rule that we talked about in the lesson. Let's say that you have the absolute value of some algebraic expression. Let's just call it u. And this is set equal to some positive number. Let's just use 12, since that's our number over here. Well, basically, this sets up as u could be equal to 12, then or u is equal to negative 12. right? In this case, it's very simple. To prove this, you could just plug in 12 here. The absolute value of 12 is 12, so you get a true statement. Or the absolute value of negative 12, if you plug that in, is also 12, so that would be true as well. So how can we use this rule on this guy here? Well, just consider this outer guy here as being set equal to 12, right? So what's inside is your u. So you would take what's inside here. Let me just highlight this in a different color. So this guy right here, we would set it equal to 12. Then we would say, or it's equal to negative 12, right? Either way, you get a true statement. If you got 12 in there, well, the absolute value of 12 would be 12. If you got negative 12 in there, well, the absolute value of negative 12 would be 12 as well, just like we saw here. Okay, let's get rid of this, and let's just set this up. So we will have the absolute value of 2x minus 1 minus 3 is equal to 12. Then I'm going to go or the absolute value of 2x minus 1 then minus 3 is equal to negative 12. Now, when you solve these types of problems, sometimes you'll get a setup where there's no solution. Okay, so you're going to see that over here on the right. I'll get to that in a moment. So for these two guys, the first thing you'd want to do is isolate the absolute value operation. So this guy right here and this guy right here. Okay, so on the left, you would just want to add 3 to both sides of the equation. This would cancel. You'd have the absolute value of 2x minus 1, and this would be equal to 12 plus 3 is 15. Let's say or. Over here, again, I'm going to isolate this guy. So we'd say the absolute value of 2x minus 1. Again, I'm just going to add 3 to both sides of the equation. Let me make this 3 a little bit better here. Let's cancel this, and we'll say it's equal to negative 12 plus 3 is negative 9. Now, before we go any further, do you see a problem with this guy on the right? Well, yeah. You have isolated your absolute value operation, and you're saying it's equal to some negative number. That is not possible. The absolute value operation will give you something that is 0 or positive only, right? So your answer cannot be negative there. So what we would do here is just say that there's no solution, right? So this is no solution, and that is just for this guy on the right. On the left, we can get a solution, right? The absolute value operation can give us positive 15. So for this one, again, you turn to your rule. We would say the absolute value of u, in this case, u is the 2x minus 1, that's equal to, let's say, 15. Well, then u is equal to 15, or u is equal to negative 15, okay? So we just have to set this up. So we would say that 2x minus 1 is equal to 15, or 2x minus 1 is equal to negative 15. So two simple equations to solve. Let's add 1 to both sides. This cancels. We'll have 2x is equal to 15 plus 1 is 16. And then I'm just going to divide both sides of the equation by 2. We'll cancel this. We'll say that x is equal to 16 divided by 2 is 8. Then over here, let's add 1 to both sides of our equation. We'll cancel this. We'll say 2x is equal to negative 15 plus 1 is going to give me negative 14. Let's divide both sides of the equation by 2. We'll cancel this. We'll say that x could also be negative 7. So those are your two solutions. X could be 8 or x could be negative 7. You can pause the video and go back to the original equation and check each one. You'll see that the left and the right sides are equal. I'll just tell you in advance, I've already verified them and they both work. All right, let's take a look at problem number 2 now. So here we have the absolute value of, and then it's the absolute value of 5x minus 7, then plus 4, and this equals 10. So just like we saw before, we're going to consider this outside guy here, and we will say that the absolute value of 5x minus 7, then plus 4 is equal to 10. Then we'll say or the absolute value of 5x minus 7, and then plus 4 is equal to negative 10. Okay, so those are the two scenarios. Now again, you want to isolate your absolute value bars in each case. So on the left, I would subtract 4 away from each side. This would cancel away. You have the absolute value of 5x minus 7 is equal to 10 minus 4 is going to give you 6. Then over here, if we subtract 4 away from each side, again, you're going to see you have a problem. So this is the absolute value of 5x minus 7 is equal to negative 10 minus 4 is negative 14. And again, when you think about it, this is isolated. So the absolute value of 5x minus 7, it's not possible for that to give you a result of negative 14, right? This over here on the right has to be 0 or some positive number. So once again, for this scenario, we'll say there's no solution over here on the right. So no solution. Now on the left, we can have the absolute value operation give us positive 6. That's okay. So we would say that, again, 5x minus 7 is equal to 6, or the 5x minus 7 would be equal to negative 6. So here, let's add 7 to both sides of the equation. This cancels. We have 5x is equal to 6 plus 7 is 13. Let's divide both sides of the equation by 5. Let's cancel this and say x is 13 over 5. Over here, let's add 7 to both sides of the equation. This will cancel. You'll have 5x is equal to negative 6 plus 7 is going to be positive 1. Let's divide both sides of the equation by 5. Let's cancel this. So x could also be 1/5. All right, let's take a look at problem number 3 now. So we have the absolute value of x plus 1, then plus the absolute value of 3x minus 7, and this equals 12. Now, this type of problem is extremely tedious to solve, and I got a lot of questions and comments and emails about it when I did it in the lesson, so I want to take my time on this first one, and then we can go quicker on the next ones. So the first thing is you have to realize that the absolute value equations that we've solved up to this point, they had a particular strategy, right? So you wanted to isolate the absolute value on one side. Let's say you had the absolute value of some algebraic expression u, so this is isolated, and let's say it's equal to some positive number k. So this is a normal case. We say u is equal to k, or u is equal to the negative of k. All right, so we cannot do that here because you have two absolute value operations involved. So this does not apply here. Now, the other scenario is you have the absolute value of some algebraic expression u is equal to the absolute value of some algebraic expression w. Well, in this case, you would say u is equal to w, or u is equal to the negative of w. But again, we can't do that here because you have the two absolute value operations, but then you have this number over here that's going to stop you from setting them equal to each other. So this doesn't work either. So what can we do in this particular case? Well, we're going to turn to our rule for absolute value, something that we talked about in Algebra 1. We're going to say that the absolute value of x is equal to x if x is non-negative, so if it's greater than or equal to 0. And then the absolute value of x is equal to the negative of x if x is less than 0. Now, how can we use this simple definition to get an answer here? Well, notice that we're developing a rule for when we can drop the absolute value bars and what we need to do. In other words, if what I plug in for x here is non-negative, so if it's 0 or positive, I can just drop the absolute value bars and I get my answer. So in other words, if I had the absolute value of 0, I could drop the absolute value bars and I just get 0. If I had the absolute value of, let's say, 2, I could just drop the absolute value bars and I get 2, right? So it's nice and simple. But if I plugged in a negative here, or something that's less than 0, well, then I have to do additional work. I can't just drop the absolute value bars. So the absolute value of, let's say, negative 9 is not just negative 9. I have to put a negative out in front that's going to flip the sign. So the negative of negative 9, that's going to give me positive 9. Okay, so this is what you need to understand. You're splitting things into different cases, okay? So what I'm going to do is apply this strategy to this guy and this guy. So in other words, let me erase this. If I wanted to develop a rule for dropping the absolute value bars with this guy, we would say the absolute value of x plus 1 is simply equal to x plus 1. We'll say if x plus 1 is non-negative, so if it's greater than or equal to 0. And then we'll say the absolute value of x plus 1 is equal to the negative of x plus 1 if x plus 1 is less than 0. Okay, so this is a simple inequality to solve. We would subtract 1 away from each side. So let me actually just erase this in each case and just put this as a negative 1 on the right side of each. Okay, so if x is greater than or equal to negative 1, then basically we could just drop the absolute value bars, right? We would just have x plus 1 as our answer. You can try that by just saying, let's say we pick something like positive 2. So the absolute value of 2 plus 1 is equal to, well, it's the same thing as if I just drop the absolute value bars, right? It's 2 plus 1, which is 3. Okay, you can see our rule works. Now, the other one, let's say I had something that's less than negative 1. So let's say I pick negative 2. Well, I have negative 2 plus 1. Well, I can't just drop the absolute value bars, right? If I did, I'd have negative 2 plus 1, which is negative 1, which is not the right answer, right? You would want to say that this is the negative of this negative 2 plus 1, right? I've got to flip the sign because of the absolute value operation. So negative 2 plus 1 is negative 1, and so this would be the negative of negative 1, which is positive 1, right? And if you took the absolute value of negative 1, you know you would get positive 1. So this is going to be our rule, okay? So this is the basic setup or strategy. Now, you don't have to go through and write this each time. what you would basically do is come down to a table or a number line and just think about where it's 0, and then anything that's less than that, you want the negative of that expression, and then anything where it's 0 or positive, you want the expression, right? So you just drop the absolute value bars. So let me put an interval here from negative infinity going up to and excluding -1. And in this particular case, we want the negative of this quantity x plus 1. So we want the negative of this quantity x plus 1. Now I'm going to put the interval here in a moment. We have to work on that other one. But I do know that if it's -1 or larger, then I don't need the negative of this guy. I can just drop the absolute value bars. So it would just be x plus 1 and then x plus 1. Okay, so let's go back up and let's think about this other guy. So let's get rid of this and let's think about this other guy. So we have the absolute value of 3x minus 7 is equal to, again, I'm just going to drop the absolute value bar, so 3x minus 7. This is if, again, this expression is non-negative. So we'll say that 3x minus 7 is greater than or equal to 0. And then we'll say the absolute value of 3x minus 7 is equal to the negative of 3x minus 7. This is if, we'll say 3x minus 7 is less than 0. So for this one, you would add 7 to both sides. Let me just do this on both of these at the same time. And then you would divide both sides by 3. So basically, you would say that if x is greater than or equal to 7/3, that the absolute value of 3x minus 7 can be found by just dropping the absolute value bars, right? And then if you're less than 7/3, well, then the absolute value of 3x minus 7 can be found as the negative of this quantity 3x minus 7. So we're going to go down here, and we're going to think about the interval between -1 and 7/3, and then the interval that's greater than 7/3. Okay, and I'll talk about -1 and 7/3 in a moment. I know some of you are going to be confused as to why I didn't include it. So first off, anything that's less than 7/3, we know that we want the negative of this guy, right? So the negative of the quantity 3x minus 7. So the negative of the quantity 3x minus 7, and then the negative of the quantity 3x minus 7. And then if I'm greater than 7/3, then I just want the expression 3x minus 7. So 3x minus 7. Okay, so let me come back here and just copy this equation. So the absolute value of x plus 1, then plus the absolute value of 3x minus 7. This equals 12. Okay, so let me pause for a minute and talk about something that's probably a question that you're going to ask. I get this question a lot. So when some people set up these problems, you'll see them include -1 here. And the reason you would include -1 here is because at -1, this guy right here is going to be 0. Plug in a -1 there. -1 plus 1 is 0. The absolute value of 0, again, you could just drop the absolute value bars. So you could include that there. And then the same thing over here, you could include this right here if you wanted to, okay? Because if you plug in a 7/3 there, this guy right here is 0, and the absolute value of 0, again, you could just drop the absolute value bars. So if you're doing this problem on your own and you want to include it, you can, okay? It's up to you. This is just scratch work. So I always like to consider those guys separately. Okay, so this is just my strategy, the way that I do it. If you want to do it the other way, it's still valid. It's not going to change your answer. We're going to see in a few problems one where we actually get one of these guys as our solution. That is pretty much a special case, and I'll show you what to do when that happens. So from this point, all we would need to do is basically use our rule to set up a different equation for each interval. We would solve that equation, and then we would see, does the solution lie in the interval? If it does, we'll accept it. If it doesn't, we will reject it. Okay, so let's start with anything that's less than -1. So building my equation here, again, if I drop the absolute value bars, I use this rule. So the negative of this quantity x plus 1, and then plus the negative of, you might as well just write minus, the quantity 3x minus 7. Again, that's so I can drop these bars, and this equals 12. So I'm going to solve this, and if I get something that's less than -1, I can accept it. If it's not less than -1, I will reject it. So let's go down, we'll come back up. So here we have the negative of x plus 1, so it's just basically negative x and then minus 1, just multiplying each guy there by -1. And then here I'll do the same thing, so -1 times 3x is minus 3x, and then -1 times -7 is going to be plus 7. This equals 12, right? So if you struggle with that, you can always just put a -1 there and put plus a -1 there, and you're just distributing this to each in case you are confused about that. Okay, so from here, -x minus 3x is -4x, and then -1 plus 7 is going to be positive 6, and this equals 12. We will subtract 6 away from each side of the equation. Let's cancel this. We get negative 4x is equal to 12 minus 6 is going to be 6. Divide both sides of the equation by negative 4. And we'll say that x is equal to, let me show this is canceling. You would have a negative because a positive over a negative is a negative. And 6 and 4 are each divisible by 2. 6 divided by 2 is 3. And 4 divided by 2 is 2. So you get x equals negative 3 halves. Coming back here, let me write x is equal to negative 3 halves. Is this in my interval? Yes, because I'm looking for something that's less than negative 1. This is basically negative 1.5, so it's to the left of negative 1 on the number line, right? So this is in this interval, so we would accept this solution. So I'll just put a check mark there. Now, in the next interval, this is between negative 1 and 7/3, so we're going to use our rule. So again, for this one, you could just drop the absolute value bars because this one's going to be positive in that interval. Or again, if you wanted to include negative 1 itself, then it would be non-negative. So we will just say x plus 1. Then to drop this guy, again, this guy is negative in that interval. So let's put minus this quantity 3x minus 7. And again, you can go plus negative 1 if that's a little bit easier for you. And this equals 12. Okay, so we have x plus, we have 1. The negative 1 times 3x is minus 3x. The negative 1 times negative 7 is plus 7, and this equals 12. Okay, so we will have x minus 3x, which is negative 2x. And then 1 plus 7 is going to be 8, and this equals 12. So here we would subtract 8 away from each side of the equation. This cancels. You have negative 2x is equal to 12 minus 8 is going to be 4. Let's divide both sides of the equation by negative 2. And we're going to cancel this and say x is equal to 4 divided by negative 2 is negative 2. So coming back, I'm just going to write x is equal to negative 2. Now, is this in its interval? No, right? Because this is between negative 1 and 7/3. Or again, if you wanted to include negative 1, you could say that's part of it, but it does not fit in this interval here. So you're going to reject this, okay? You don't want that answer. So then now I'm working with this interval between 7/3 and infinity. Or again, if you wanted to include 7/3, you could if you wanted to. It's not going to change anything. So we're going to say that we can just drop the absolute value bars because everything is going to be either non-negative if you included 7/3 or positive if you didn't. So we'll say x plus 1, then plus 3x minus 7 is equal to 12. So we'll say x plus 3x is 4x, and then 1 minus 7 is going to be negative 6, and this equals 12. Let's add 6 to both sides of the equation. This cancels. We get 4x is equal to 12 plus 6 is 18. Let's divide both sides of the equation by 4. So we're going to cancel this with this, and we'll say x is equal to, for 18 and 4, they're each divisible by 2. 18 divided by 2 is 9. 4 divided by 2 is 2. So this is x equals 9 halves. So coming back up here, I'll say x is equal to 9 halves. Now 9 halves is 4.5. And if you think about 7/3, I would say that's 2 1/3. So 4.5 is obviously greater than 2 1/3. So it fits in this interval, so you can accept this solution. So going back, let me just write this out here. You have x is equal to negative 3 halves, and then also 9 halves. So coming back here, I'll just paste the solution there. So this would be our full solution. Again, you can always pause the video and check each one of these, make sure it works in this equation. I've already verified each one of these solutions. You can even take that solution that we rejected, that negative 2, you can plug it in and see it's not going to work. All right, let's take a look at problem number 4. So we have the absolute value of 4x minus 7, then minus the absolute value of 5x plus 2, and this equals 6. So we spent a lot of time on the last example like this. So for this one, I'm going to go a lot faster. Again, the first thing I'm going to do is figure out where this is 0 and where this is 0. And then I'm going to set up intervals on my number line. So we're going to say 4x minus 7 is equal to 0. We'll add 7 to both sides. We'll cancel this away and say 4x is equal to 7. Divide both sides by 4. And we'll get x is equal to 7/4. Okay. So the other one, we're going to set 5x plus 2 equal to 0. Let's subtract 2 away from each side. We'll say 5x is equal to negative 2. Divide both sides by 5. We'll cancel this. We'll say x is equal to negative 2/5. Okay, so we have those two guys. And basically, we're going to use them to set up our intervals on our little table here. Let's paste this in here. So negative 2/5 is my leftmost value. So I'll say from negative infinity up to and excluding negative 2/5. Again, if you want to include negative 2/5, you can. You could say this is negative 2/5 here. And then you're going to exclude 7/4. So that interval there. Again, my preference is to do it this way. If you want to do it the other way, it's up to you. It will not change your answer in any way, shape, or form. Okay. And then the other one is going to be from 7/4 out to positive infinity. Again, if you want to include it, you can. Won't change your answer. I am going to exclude it. Okay, so let's look at our equation. We have the absolute value of 4x minus 7, then minus the absolute value of 5x plus 2, then this equals 6. Coming back here, again, in this interval right here, both of these guys are going to be negative. So I want the negative of this quantity 4x minus 7, and then I want the negative of this quantity 5x, and then plus 2. Then for this one right here, this guy will be positive, or you could say non-negative if you included this. So I'll just have the 5x plus 2 here. And this guy is still going to be negative. So the negative of this quantity 4x minus 7. And then in this guy right here, again, if you included this, then this guy would be non-negative and the other guy would be positive. But if you exclude it like I did, they're both positive. So 4x minus 7, again, it doesn't change your answer if you include it or include it. And then you have 5x plus 2. Okay, so let's go through and set up our equations. So in the first case, they're both negative. So you want the negative of this quantity 4x minus 7. And then you have a minus. So you have to be really careful here. This is minus, and then you want the negative of this. So let me put this inside of brackets or something so I don't make a mistake. So the negative of this quantity 5x plus 2. Just be really careful if you have a negative, okay? Then this equals 6. So here I'm going to distribute this negative to each. So this is negative 4x and then plus 7. And then I'll put my minus sign out in front. And then inside of here, this would be negative 5x and then minus 2. And then to distribute this negative, this would be a plus. And then this would be a plus also. Okay, so make sure you use brackets or parentheses so you don't make a sign mistake with something like this. So then this equals 6. Okay, so negative 4x plus 5x is just x. And then 7 plus 2 is 9. So plus 9, and this equals 6. Let's subtract 9 away from each side. We'll cancel this and say that x is equal to 6 minus 9 is negative 3. So let's say x is equal to negative 3. Now, is that in this interval? Again, this is anything that's less than negative 2/5, and negative 3 would be in that interval, so we can accept this solution. So let's look at this interval here between negative 2/5 and 7/4. So we have that this guy is negative and this guy is positive. Okay, so let's take this first guy and say it's the negative of the quantity 4x minus 7, then minus. Now this guy is positive here, but again, because you have this negative here, you have to subtract the whole thing away. So this is really easy to make a mistake on. Go ahead and wrap this in parentheses so that you don't make a sign mistake because you have to subtract away 5x and then also 2. Then this equals 6. So here we'll have negative 4x and then plus 7. Again, just distributing the negative to each. And then I'm going to do the same thing here. So this is minus 5x and then minus 2. And this equals 6. Okay, so negative 4x minus 5x is negative 9x. And then 7 minus 2 is going to be 5. So plus 5. This equals 6. We'll subtract 5 away from each side. We'll say negative 9x is equal to 6 minus 5 is going to be 1. And then I'll divide both sides by negative 9. We'll say that this cancels. X is equal to negative 1/9. So let's put x is equal to negative 1/9. So is that in this interval? Well, negative 2 divided by 5 is negative 0.4, okay, as a decimal. And then this negative 1/9, that's negative 0.1 repeating, okay? So this value right here, this negative 1/9, is a larger value, or is to the right of this negative 2/5, and it's to the left of this 7/4, okay? So we can actually accept this solution. Okay, let's look at this last interval. In this case, we can just drop the absolute value bars in each case. So we'll have 4x minus 7, and then minus, again, when I drop this, make sure to wrap this in parentheses. I want to subtract the whole thing away. Then this equals 6. So here you'll have 4x minus 7, then again, minus 5x, and then minus 2, just distributing this to each, and this equals 6. Okay, so 4x minus 5x is going to be negative x, and then negative 7 minus 2 is going to be negative 9. This equals 6. So we're going to add 9 to both sides of the equation. This cancels. You get negative x is equal to 6 plus 9 is 15. Let's multiply both sides by negative 1. And that's going to give me that x is equal to negative 15. So let's put x is equal to negative 15. Now, obviously, this is not in this interval, so you can just reject this solution. So your valid solutions here, you would say that x is equal to negative 3, or x is equal to negative 1/9. Let's put that there. And again, you can pause the video and check each one of these solutions and verify that they work. And you can also check that x equals negative 15 does not work. All right, let's take a look at problem number 5 now. So we have the absolute value of x minus 2, then plus the absolute value of x minus 7, and this equals 5. So this problem is a bit tricky. So maybe you tried to solve it and you couldn't get it. So let's just go through it here. I'm going to start in our usual way. I'm going to think about x minus 2. Basically, where's that equal to 0? So let's set that equal to 0. We'll add 2 to both sides of the equation. We'll cancel that. So we'll say x is equal to 2. So we know at this point that basically if x was 2, then this would be 0. Right? If x was something greater than 2, this would be positive. And if x was something that was less than 2, this would be negative. All right, let's slide this over here. Then we also have this x minus 7. Let's set that equal to 0. Add 7 to both sides. We know this is x is equal to 7. Okay, so again, if x was 7, this is 0. If it's greater than 7, this is positive. And if it's less than 7, then this is negative. Let's put x is equal to 7 here. So let's go to the table and let's set up our intervals. So you're going to have one that's from negative infinity going up to and excluding 2. And then I'm going to do this in 2 ways just to show you the difference. So here I'm going to go between 2 and 7. And with this one, I'm going to go including 2, but excluding 7. So a lot of people prefer to do it this way. I'll show you the difference between the two on this one, because what's going to happen is when you solve this, you're going to end up with 2 as a solution. And then here, you're going to get something weird. You're going to get an identity. So let's just keep going, and then I'll explain more as we go. Then over here, let's split this into 2. So we'll say this is anything greater than 7, and I'll also include 7 here for those that want to see it. Okay. Before I actually set anything up, I want to go up, and I want to advise you, if you're struggling with this problem, to take the left side of this and use an online graphing calculator like Desmos. It's completely free. I'm going to use MathGV. So you can just type this in, and you want to see where is that function's value equal to 5. In other words, where is the y value equal to 5? So go find where the function's value is 5 and look for the associated x values. So I have used MathGV to make a little graph for us. And so again, I'm looking for where the function's value is 5. So I'm coming across, and you'll see that it's right here through right here. And you can highlight the whole thing if you want. And basically that starts where there's an x value of 2 and continues through where there's an x value of 7. So graphically, I can see that the solution is x is greater than or equal to 2 and less than or equal to 7. So we know that from this graph. Now let's see if we can figure this out algebraically. Let's come back up here and let's grab this guy. So we have the absolute value of x minus 2 plus the absolute value of x minus 7. This equals 5. So in this first column, I know that everything is negative. So I would have the negative of this quantity x minus 2. So that's negative x and then plus 2. I just distributed the negative. Now here, whether you use this method or this method, basically you can just drop the absolute value bars. Here you could say that it's non-negative. Here you could say it's positive. Either way, it's just x minus 2. And then here it will be positive, so it's just x minus 2. Okay. With this x minus 7, it's going to be negative here and then also here, right? So I'm going to say that's negative x and then plus 7. Again, just distributing the negative to each guy. So then negative x plus 7. And then again, when I get here, whether I use this guy or this guy, it's either going to be non-negative with this case or positive with this case. Either way, just drop the absolute value bars. It's x minus 7. So whichever one you want to do. Okay. So coming down here, I'm going to solve the first case, and we're going to get something that's a bit weird. Okay. So the solution we're going to get is positive 2. Okay. So I'm going to come through here and say this is negative x plus 2. And then this is a plus sign here. So you can just go minus x plus 7, and this equals 5. Let's just solve this really quickly. Negative x minus x would be negative 2x. And then 2 plus 7 would be 9, and this equals 5. Let's subtract 9 away from each side. We'll cancel this. I'll just say this is negative 2x is equal to 5 minus 9 is going to be negative 4. Divide both sides by negative 2. This would cancel, and we're going to see that x is equal to positive 2. Okay. So does that work? Well, currently it doesn't, right? Because in this interval, again, I'm coming from negative infinity and I'm going up to and excluding positive 2. So I would say x equals 2. That's going to have to get rejected right here, okay? Now you might have some questions because again, when we go back to the graph, you can see that 2 is clearly included in the solution, and so is 7. So the way we're going to get that is basically when we think about this guy right here. So I'm going to solve this, and I'll come back up and I'll talk about this scenario and this scenario. Okay, so this is where if you're confused about including it or excluding it, this is where you can get some clarification. Okay, so for this one, we would just do x minus 2. And then again, because this is a plus sign, I can just go minus x and then plus 7, and this equals 5. So if you have x minus x, that's 0, right? So that's going to basically cancel. So this is going to go away. So now I have negative 2 plus 7, which is 5. So you get 5 equals 5. So we saw equations like this earlier on in the course. They're called identities. They're always true for any value of x, but we have to only consider the values of x that are in our interval. If I get something like this, I'm just basically going to say that this tells me that its x is greater than 2 and less than 7. Okay, so here's where you have to make a decision. If you're using this method right here, which again includes 2, then at this point I can legally include 2, right? Because again, the setup is the same whether I think about it this way or this way, right? If this was 0, well, then I could just drop the absolute value bars. If it's positive, again, I can also just drop the absolute value bars. So you can legally include that now. What I always do is just use this, and then I say, okay, does 2 work? I go back and plug it in. 2 minus 2 would be 0. So basically here you would have 2 minus 7, which is negative 5. And then the absolute value of negative 5 would be 5, right? This is 5 equals 5. That's a true statement. So that's how I would go about including 2. But again, if you want to do it this way, that's up to you. It's a little bit quicker. Now, on the other end, you see that 7 is excluded, right? It's excluded here and it's excluded here. But again, when we think about coming back to this graph, you'll see that 7 is included. So how are we going to get that part of the answer? Well, that's going to come in here. So let's come down and let's solve this part. So we have x minus 2, and then again, this is a plus, x minus 7, and this equals 5. So here, you're going to get x plus x, which is 2x. Negative 2 minus 7 is going to be negative 9, and this equals 5. So what we'll do here is add 9 to both sides of the equation. This will cancel, and we'll say this is 2x is equal to 5 plus 9 is 14. Let's divide both sides of the equation by 2, and we'll say that x is equal to 7. So coming back up here, I have x equals 7, okay? Now, again, if you've included 7 here, then you're done. Basically, you can just combine these and say that x is greater than or equal to 2 and less than 7, and then you would say, or x is equal to 7. Now, this is easy to combine because you can just say that this is basically x is greater than or equal to 2 and less than or equal to 7, right? That's easy to combine. But let's say you did my method that I've been talking about. Well, here you're not done because technically 7 is not in there. So you'd have to take the extra step of plugging 7 in to verify that it's going to work, right? Just like I did with 2. So in this particular case, I would say that 7 minus 2 is 5. So you'd have the absolute value of 5. And then this right here, 7 minus 7 is 0, so that's gone. So the absolute value of 5 is equal to 5. You get 5 equals 5, so that works. So that's how I could verify that 7 is part of the solution. So again, just depending on the method you want to use. Okay, so let's go back up and let's write our solution. So we'll say x is greater than or equal to 2 and less than or equal to 7. And again, if you have doubts about this, you can, again, just go to the graph and see that that's the solution. You can also pick values that are in that interval. So between 2 and 7, including 2 and 7, we already saw 2 and 7 work, but you could just pick something like 3 or 3.5 or 3.25 or whatever you want, anything in that interval, plug it in and verify that you get a true statement. Let's just pick one real quick, and then we'll conclude the problem. So let's just say we chose 3. So 3 minus 2 would be 1. So this is the absolute value of 1, which is 1. Then plus 3 minus 7 would be negative 4. The absolute value of negative 4 is 4. Does that equal 5? Yes, you get 5 equals 5. So this is a true statement. So this would be our solution. X is greater than or equal to 2 and less than or equal to 7. All right, let's take a look at problem 6 now. So here we have the absolute value of x minus 7, then minus the absolute value of x minus 3, and this equals 7. So in this particular case, I'm just going to tell you in advance, you're not going to get a solution. So I thought we would look at an example like this. So here we can kind of speed through this. We know that this one is just x is equal to 7, and for this one, it's just x is equal to 3. I think we don't have to waste time with that anymore. Let's come down here. Let's paste that here. So I'm going to have an interval from negative infinity up to and excluding 3. And then here it's going to be between 3 and 7. And again, if you want to include 3, you can include 3 there. It's not going to matter, but I'm just going to exclude it. And then you want anything that's greater than 7 right here. And then basically here, if you wanted to, you could include 7. But once again, I'm going to exclude it. Okay, let's look at our equation. I'm just going to copy this. So this is the absolute value of x minus 7. Then minus the absolute value of x minus 3. This equals 7. And let's go through our cases. So in this first guy, this leftmost guy, they're both negative. So I want the negative of the quantity x minus 7. Let me just distribute this now. This is negative x plus 7. And then basically, I'm going to have that again right here. So this is negative x plus 7 again. And then in this guy right here, this is going to be positive. So I'm going to say this is x minus 7. Okay. For this next guy, you have x minus 3. So that's going to be negative here. So that's the negative of x and then plus 3. So I just distributed a negative to the x and then the negative 3 to get this. And then here it's going to be positive and here it's going to be positive. So it's just x minus 3. And again, if you're including things like the 3 and the 7, nothing is going to change here, okay? So it won't make any difference whatsoever. So let's go through and set up our first equation. So this is going to be negative x plus 7. You have to be really careful because of this minus. So minus the quantity negative x plus 3, and this equals 7. So let's solve this real quick. This is negative x plus your 7, and this is the negative of negative x, which is plus x, and then the negative of 3, which is negative 3. This equals 7. And then from here, you have negative x plus x. That's gone, basically, right? Those are going to cancel. So you have 7 minus 3, which is 4. So you get 4 equals 7, which is a false statement, right? So this is false. So there's no solution in that first one. You can come up here and just put no solution if you want, or you can just leave it blank. I'll just put no solution like that. Okay. For the next guy, we're trying to get between 3 and 7. So this is negative x plus 7, and then minus. Again, you have to be careful here. You're plugging in an x minus 3 where this is right here, but you have to wrap it in parentheses. You have to subtract the whole thing away. That's very important. So this would give me negative x and then plus 7, and then basically minus x and then plus 3, and this equals 7. So negative x minus x would be negative 2x, and then 7 plus 3 is 10, so plus 10, and this equals 7. So let's subtract 10 away from each side. Let's cancel this. You get negative 2x is equal to 7 minus 10 is going to be negative 3. Let's divide both sides by negative 2. This cancels, and you're going to get x is equal to 3 halves. So let's put x is equal to 3 halves. 3 halves, or 1.5, is to the left of 3 on the number line. So this is not going to work. This has to be rejected. Okay, so now we're down to the last guy, and we're just going to drop the absolute value bars in each case. So x minus 7, and then minus, again, make sure you use parentheses here, the quantity x minus 3, and this equals 7. I think you can see this is not going to work, because you can have x minus an x, so that is going to drop out, and this is not going to be 7 over here, so it's not going to be an identity, it's going to be a contradiction, right? So it's not going to work. But let's just go through it for completeness. This is x minus 7, and then minus x, and then plus 3. This equals 7. Again, this and this, that's going to cancel, right? X minus x is 0. Negative 7 plus 3, that's going to be negative 4. So you get negative 4 is equal to 7, which is false, right? So there's no solution there. So coming back, I'm just going to write that there's no solution, right? So this guy, this absolute value of x minus 7, then minus the absolute value of x minus 3, that's never going to be equal to 7. So coming back, I'm just going to put that there's no solution. And again, if you're a bit lost on this one or you have some doubts, you can always take this right here, this left-hand side, and you can graph it. You can type it into Desmos or any online calculator as it is. So the absolute value of x minus 7, then minus the absolute value of x minus 3. You could put f of x is equal to that if you wanted to. You could put y is equal to that if you wanted to. It's all going to produce the same graph. And you want to see where is the y value equal to 7. Pulling this up on MathGV, again, you're going to see that it's never going to be equal to 7. Okay, that's why there's no solution. If I had said something like, where is it 0? Well, this is a y value of 0. Just look for the corresponding x value. That's going to be 5, right? So if this had been, this guy is equal to 0 here, we would have found a solution of x equals 5, right? So this is one way you can clear up your doubts about things. You can just graph it and see what's going on. In this case, you see that that function that you create is never going to have a value of 7, no matter what x value you plug in. All right, let's take a look at problem number 7 now. So we have the absolute value of x minus 1, then plus the absolute value of x plus 2, then plus the absolute value of x plus 3, and this equals 5. So this one is a bit more tedious, but you use the same strategy. Okay, so it doesn't matter how many of these you have, you can just set up cases. Okay, I'm going to go through this a little bit more quickly. Now I'm going to tell you that one of these endpoints, specifically negative 3, is going to work. So that's another chance for us to look at what to do when that occurs. So for this one, you would basically say x minus 1, you set that equal to 0 and you solve. So you get x is equal to 1. For this one, x plus 2, if you set that equal to 0 and you solve, you get x is equal to negative 2. For this one, if you set x plus 3 equal to 0 and you solve, you get x is equal to negative 3. So let's grab these real quick. And I'm just going to paste this in. And let's just go ahead and say the furthest to the left is negative 3. So I want from negative infinity up to and excluding negative 3. Now for this one, if you want to include negative 3, you can. It's going to make the problem a little bit easier. And this would be up to but excluding negative 2, okay? But I'm just going to exclude it for right now, and I'm going to show you how you could solve it this way. And again, maybe I'll put it down here just for reference, okay, in case you want to do it that way. A lot of people like this method better, okay? So then the other one would be, we would have between negative 2 and positive 1. And again, you can include negative 2 there and exclude 1 there. You're always including on the left and excluding on the right, but this one furthest to the left, everything has to be excluded, okay? I specifically want strictly less than negative 3, okay? Then this one right here would be anything that's greater than 1. And again, you could write this with 1 being included and out to positive infinity. Okay, so let's get rid of this. Let's come up here and say this is the absolute value of x minus 1, and then plus the absolute value of x plus 2, and then plus the absolute value of x plus 3, and this equals 5. Let's do this one at a time. So first off, let's consider the absolute value of x minus 1. So basically, this is going to be 0 where x is 1. So I'm thinking about this column here, right? So if I include it, then at 1, it's 0, right? And anything larger is positive. So whether you're doing it this way or this way, you would just drop the absolute value bars in that case, right? So this is just x minus 1. Now, going to the left here of 1, well, it's always going to be negative, right? So I want the negative of the quantity x minus 1, and let's just do that now. That's negative x plus 1. So this is negative x plus 1. This is negative x plus 1. This is negative x plus 1. The other guy is the absolute value of x plus 2. So when x is negative 2, it's going to be 0. So again, if you had included it right there, that's where it would be 0. And then anything larger, it's going to be positive. So here it's going to be x plus 2. I could just drop the absolute value bars, either for this one or this one. And here it's going to be x plus 2, okay? And then going to the left, it's going to be the negative of this quantity x plus 2. So negative x minus 2, and then negative x minus 2. Okay. Lastly, we have this x plus 3. So that's going to be 0 where x is negative 3. So again, if you include it, that's where it's going to be. Or it's going to be positive if you're greater than negative 3. So again, either way, whether you include it or not, you could just drop the absolute value bars, and you get x plus 3 here, and you get x plus 3 here, and you get x plus 3 here. And then to the left of negative 3, which is where we are here, you would want the negative of this. So this is negative x, and then minus 3. So let's go through and consider what's going to happen. We're going to see something interesting because negative 3 is going to be a solution when we get in here. And then also it's going to be a solution when we get in here. Okay, so let's come down here and let's think about the first scenario. So we're going to have all of these guys are negative. So negative x plus 1. These are all plus signs. So just go through. We'll say plus negative x minus 2, and then plus negative x minus 3, and this equals 5. Let's just collect terms really quickly. Negative x minus x is negative 3x. And then 1 minus 2 is negative 1. And then minus 3 is negative 4. And this equals 5. Let's add 4 to both sides. We'll cancel this. And we'll say that negative 3x is equal to 9. Divide both sides by negative 3. And this is going to give me that x is equal to negative 3. Okay, this is canceling. Now, whenever you get something and it's on one of those breakpoints, well, you want to consider it. And at this point, because I use this method, I would make myself a little note to check negative 3. I would plug it in and see that it works, and I would accept it. But I would still reject it in my scratch work over here. Your teacher is generally not going to see this. This is where I'm going to reject because negative 3 is not in this interval, right? This is less than negative 3, so negative 3 is not specifically included. Now, when I solve this one, negative 3 is going to be the solution again, and here's where you have to make a decision, right? You can include negative 3 here legally because it does not change this guy right here. Whether it's negative 3 or something larger than negative 3, it's still going to be me just dropping the absolute value bars. So in this case, if you want to use this method, it's going to be a little bit quicker. But again, for myself, I would use this, and I would just test negative 3 and see, does it work? The answer is yes, so then I would include that in my solution set. So for this one, let's just go through it. So you have negative x plus 1, and then I'll just go minus x minus 2, and then plus x plus 3. This should be equal to 5. So negative x plus x, that's going to cancel. Let me just show that. This would cancel. And you have negative x. So 1 minus 2 is negative 1, and then negative 1 plus 3 is going to be plus 2, and this equals 5. Let's subtract 2 away from each side. We'll cancel this. We'll say that negative x is equal to 5 minus 2 is going to be 3. multiply or divide both sides by -1. Doesn't matter. Let's just divide both sides by -1. This will cancel, and you're going to say that x is equal to -3. So if you're using this one right here, let me write this up here maybe. So x equals -3. If you're using this right here, well, -3 is included. So you can accept this solution. Now, if you're using my method here that I like to use, when I get something that's a solution that's a breakpoint, well, I just plug it in again and see, does it work? And I know -3 works. So when I write my final solution, I'm just going to include x equals -3. Okay, so that's how I do it. So for this one, let's go through and we'll say -x plus 1, and then plus x plus 2, and then plus x plus 3 is equal to 5. So -x plus x, that's going to cancel. So you have 1 plus 2, which is 3, plus 3, which is 6. So you have x plus 6 is equal to 5. If you subtract 6 away from each side, you get x is equal to -1. So x is equal to -1. Would I accept that? Let me write that up here. So x equals -1. Well, yeah, that's in this interval and this interval, no matter which one you used in this case. So I would accept that. So x equals -1. All right, let's take this one. We're going to end up rejecting. So you have x minus 1 plus x plus 2 plus x plus 3 is equal to 5. So x plus x plus x is 3x. -1 plus 2 is 1. Then plus 3 is 4. So plus 4 is equal to 5. Let me make that better. If I subtract 4 away from each side, let's just say 3x is equal to 1. Divide both sides by 3. This cancels. You get x is equal to 1/3. Now, that is not going to be in that interval. Remember, this is anything that's 1 or greater if you're using this one, or this one is just anything greater than 1. Again, doesn't matter because here x is 1/3, right? And we have to reject that. So this would be rejected. So looking at everything, again, whether you use this method or this method, you're going to find that x is -3 or x is -1. So coming back, I'll say x is equal to -3, then or -1. And then again, if you want to do this graphically, you could take this left side here and punch it into Desmos or MathGV or whatever free calculator you want to use. And basically, the absolute value of x minus 1 plus the absolute value of x plus 2 plus the absolute value of x plus 3, just see where the function's value is 5. I see that it would be 5 just going across. Here, this is where it's -1, and then going across here, this is where it's -3. Okay, so you can verify that graphically if you have your doubts, but either way, the solution is x equals -3 or x equals -1. All right, let's take a look at problem number 8 now. So here we have 3x squared plus 16 times the absolute value of x is equal to 35. So I talked about in the lesson 2 different ways you could solve this type of problem. I'm just going to use the substitution. So first, I'm going to write this as 3 times the absolute value of x being squared, because remember, if I have x squared, that's going to be equal to the absolute value of x being squared. Those two would be equal. Then plus, we have 16 times the absolute value of x, and this equals 35. So now I'm going to let something like u or z or whatever you want to use be equal to this absolute value of x. So I'm just going to plug that in here and make a simple quadratic to solve. So this would be 3u squared plus 16u. And let's subtract 35 away from each side. So minus 35 is equal to 0. This is something we can solve using factoring. So I'm just going to put a 3u here and then put a u here. And let's set that equal to 0 there. For this guy right here, it's negative. So I know the signs are going to be different. And I'm going to subtract. I'm going to try to get the 16 in terms of absolute value. 35 is 1 times 35. And that's not going to work. And then you have 5 and 7. So that's basically it. So if you put the 7 here and the 5 here, you've got 21 minus 5, which is 16. Let's make this a plus and this a minus, and we'll be good to go. This would give us 21u, and this would give us -5u. And again, 21u minus 5u would be 16u. Okay, so we would say that 3u minus 5 is equal to 0, or u plus 7 is equal to 0. Let's add 5 to both sides, cancel this. We get 3u is equal to 5, divide both sides by 3. And we'll say that u is equal to 5/3. So let me put that up here. Put u is equal to 5/3. And then over here, I'm just going to subtract 7 away from each side of the equation. Let's cancel that. So it could also be -7. Let's put -7 there. When you solve these, you often get ones that you have to reject. So we let u be equal to the absolute value of x. So I'm just going to say that the absolute value of x is equal to 5/3, or the absolute value of x is equal to -7. And I'm just getting that by replacing this u with the absolute value of x. Okay, you can actually get rid of this. We don't need it. And you can even get rid of this if you want. You don't need it. Okay, let's bring this up here. Now, this guy on the right has no solution, right? The absolute value of x can never be -7. So we'll just put no solution for this part. And then over here, this is really simple. If the absolute value of x is set equal to 5/3, well then x is 5/3, or x is negative 5/3, right? And you can write this in a more condensed form by just saying that x is equal to plus or minus 5/3. So that would be your solution. You can pause the video and check each one and verify that they work. Okay, let's look at problem number 9. So again, we're going to use the same strategy here. Now you could clean this up first, or you could substitute first. It really doesn't matter. I think maybe we can clean up first. So let's just say negative 3x squared. I'm going to subtract 8 times the absolute value of x away from each side. So if I have 18 times the absolute value of x minus 8 times the absolute value of x, that's going to be 10 times the absolute value of x. Then basically if I subtract 2 away from each side, this is going to be 15 minus 2, which is 13. So plus 13, and this equals 0. Okay, so that's a simpler form. If you want to do the substitution first, you can do that and then simplify. Again, doesn't matter. So what I'm going to do is actually just replace this like this. Again, that's perfectly legal. And then I'm going to let u be equal to the absolute value of x. So this is negative 3u squared, then plus 10u, then plus 13 is equal to 0. And so with this one, I would actually multiply everything by negative 1. So I don't have to deal with that negative out in front. Let's change the sign of all those. And then 0 times negative 1 is still 0. Okay, so I'm going to factor this and put this as 3u, and then put this as u, put a 0 out here. And so again, this is a negative here, so I know I have mixed signs. And 13 is actually a prime number. So it can only be 1 times 13. So it can't be here because 3 times 13 is 39. It's just going to be too big. So it has to be a 13 here and then a 1 here. So let's see. This is going to be 13 minus 3, which is 10. So I need to make this negative and this positive so that I end up with 3u and then negative 13u. So positive 3u minus 13u would be negative 10u. So this is what I'm looking for. So what I'll do here is say 3u minus 13 is equal to 0, or u plus 1 is equal to 0. So this one we know that basically u is equal to negative 1, right? That one's easy. You can just subtract 1 away from each side. For this one, we would add 13 to both sides of the equation. This would cancel, and you get 3u is equal to 13. Divide both sides by 3. This cancels, so u could also be 13 over 3. Okay, so coming back up here, I'm actually just going to get rid of this. We don't really need it. So I'm going to say that we have the absolute value of x, because that's what u is. This is equal to negative 1, or the absolute value of x is equal to this 13 over 3. Okay. Once again, we know that the absolute value of x cannot be negative 1. This would be no solution. Okay, so no solution there. For this one, it's just that x is equal to 13 over 3 or negative 13 over 3. So we'll just say plus or minus 13 over 3. And you can get rid of all of this at this point and just report this as your answer. Again, you can check each one in the original equation and verify that they work. Okay, let's look at problem 10. So here we have negative 5 times the absolute value of x squared, then minus 8 times the absolute value of x, then plus 21 is equal to 8. Okay, so this one is really the same as the other ones. This part right here is meant to trip you up. A lot of books will do this, but you have to realize that the absolute value of x squared is the same thing as if I had x squared, right? These are both going to be non-negative. And it's also the same thing as if I had the absolute value of x being squared like this. In each case, you're going to get the same result, whether you have a negative, whether you have 0, or you have a positive, right? It doesn't matter what you plug in, those will always be equal. So what I can do is rewrite this legally and say this is negative 5 times the absolute value of x being squared like this, then minus 8 times the absolute value of x, then plus 21, and this equals 8. From here, again, I can just replace the absolute value of x with u. So let's say that we're going to let u be equal to the absolute value of x, and I'll say negative 5 times u squared minus 8 times u plus 21 is equal to 8. All right, for this one, let's subtract 8 away from each side. So this would be 0, and then 21 minus 8, that's going to be 13. And again, I don't want a negative leading coefficient if I'm trying to factor. So I'm going to multiply everything by negative 1. So that's positive, this is positive, that's negative, and that's still 0. So let me try to factor this. I'm pretty sure that we can. Otherwise, we can just use the quadratic formula. So this guy right here, again, with 13, it's 1 times 13 only. Okay, and this is minus, so I have mixed signs. Putting a 13 here is too big. So I'd have to put the 13 here and the 1 here. And so this is 5 and this is 13. So 13 minus 5 is 8. So I want to make sure that this is positive and this is negative, right? That way I get a negative 5u and a plus 13u. Let's make that 3 a little bit better. And so negative 5u plus 13u, that would be the 8u that I'm looking for. So we would say 5u plus 13 is equal to 0, then or u minus 1 is equal to 0. So here, let's subtract 13 away from each side. This cancels. You get 5u is equal to negative 13. Divide both sides by 5, and you get u is equal to negative 13 over 5. Now, do you need to include this? No, because u is the absolute value of x, and the absolute value of x is not going to be negative 13 over 5. So just get rid of this branch. You don't need it anymore. We're just going to consider that u minus 1 equals 0, and that's the solution of u equals 1. Okay, so let's get rid of all this. We're just going to come back up here and say that the absolute value of x, which was u, is equal to 1. So that means x is equal to 1 or negative 1. So you could go plus or minus 1 like this. So that's your solution. Again, you can always pause the video at this point and check and verify that 1 and negative 1 work. All right, let's take a look at our practice test. We're told here to solve each inequality, write in interval notation, and graph. So if we look at the first problem, we have the absolute value of 1 minus 5x is greater than or equal to 36. So when we solve an absolute value inequality, we always want to make sure that our absolute value operation is isolated on one side and we have a single number on the other. So we already have that here. So basically we just go into our rule, and if we have a greater than or equal to or a greater than, then we want to set up a compound inequality with or. So for the first one, it's really simple. Just drop the absolute value bars and copy what you have. So you have 1 minus 5x is greater than or equal to 36. Then you're going to write your keyword or. And then for the next one, you drop the absolute value bars. So 1 minus 5x. You're going to flip the direction of the inequality symbol. So now it's going to be a less than or equal to. And then you're going to change this guy into a negative. So this would be negative 36. So really, you just have to remember to flip the direction of the inequality symbol so it becomes a less than or equal to, and then change this guy into a negative so you get negative 36. Okay, so now pretty much we just have to solve this compound inequality. Pretty easy to do. Let me start over here on the left. I'm just going to subtract 1 away from each side of the inequality. This would cancel, and I'll have negative 5x is greater than or equal to 36 minus 1 is 35. Let's divide each side of the inequality by negative 5. And remember, if I divide both sides of an inequality by a negative, I have to flip the direction of the inequality symbol. So because it was a greater than or equal to, it's going to become a less than or equal to. And let me show this as canceling here. And we'll say that x is going to be less than or equal to negative 7. So I'm actually just going to erase this, and we'll list this as x is less than or equal to negative 7. Okay, over here, I want to solve this guy as well. So let's subtract 1 away from each side of the inequality. This would cancel. We'll have negative 5x is less than or equal to. Negative 36 minus 1 would be negative 37. Let's divide each side of the inequality by negative 5. And remember, if you divide both sides of an inequality by a negative, you have to flip the direction of the inequality symbol. So let's go greater than or equal to here. This would cancel. So you have x is greater than or equal to. This would be 37, which is a prime number, over 5. So let's erase this. So we have our solution that says that x is less than or equal to negative 7, or x is greater than or equal to 37/5. So remember how to write this in interval notation. I'm going to start by saying that x could be anything from negative infinity up to and including negative 7. So let me put a bracket there and a parenthesis there. And then it's going to be the union with this guy right here, which is anything from 37 over 5 out to positive infinity. So again, this is included. So I put the bracket next to 37 over 5. Now, graphically, it's kind of hard to show this because you have a non-integer value here. So typically you have a number line from, let's say, negative 10 to positive 10, something like that. But as you get into more difficult numbers to display, you could just do something like this, just for the sake of showing it. And basically what I want is to show that x could be anything that's less than or equal to negative 7. So let me put a bracket here at this notch. I'll notate this as negative 7. And I'm just going to shade everything to the left like this. And then over here, let's just say this is 37 over 5. And I'm going to put a bracket here facing to the right, and I'll just shade everything to the right like this. Okay, let's look at problem number 2. So this one is a little bit different in terms of the setup. So now we have the absolute value of 10 plus 9x is less than 73. So it's the same idea, but now you're using the keyword and.
So you're looking for the intersection of the two solution sets. And what you would do is you would drop the absolute value bars. So you would have 10 plus 9x basically is less than 73. Then you're going to use the keyword and then you would have 10 plus 9x, so just write your expression. You would flip the direction of the inequality symbol, so just like you did before, so that now it's a greater than, and you would make this guy negative, so this is negative 73. Now you can solve it like this, but I think it's probably much faster to just write it as a three-part inequality because you have the same expression here, 10 plus 9x and 10 plus 9x. So just write that in the middle, so you're 10 plus 9x like this. And we know that it has to be less than positive 73. And it also has to be greater than, okay, so greater than negative 73. So it's probably easier just to set it up in this format, a lot quicker to solve it. Let's get rid of that. Let's slide this up here. And let's go ahead and solve this. Again, for a three-part inequality, we would do the same thing to each part. And first, we would isolate this 9x. So I would subtract 10 away from each part here, just like this. And of course, this would cancel. Negative 73 minus 10 would be negative 83. Let's put that this is less than our 9x, which is less than 73 minus 10 is going to be 63. And what I'll do to get x by itself, since 9 is multiplying x, I'll divide each part here by 9. Just make sure you do it to everything. And let's cancel this with this. So x will be in the middle, and it'll be greater than, you have negative 83 over 9. And I'll say, and it's less than 63 over 9 is 7. Now, in terms of this fraction here, 83 is a prime number, so it's not something you could simplify. Okay, so for interval notation, neither of these guys is going to be included. So let's put a parenthesis here. I'll put negative 83 over 9, and then comma, I'll put a 7, and then a parenthesis here. Again, this is not included, and this is not included. So we're going to match this when we make our graph. So let's put this notch as negative 83 over 9, and let's say this notch is positive 7. And again, neither is included, so let's put a parenthesis here, and let's put a parenthesis here, and then you would just shade everything in between. So let me just shade all of this in between. So what we're saying here is that x can be any value between negative 83 over 9 and 7, with those two values being excluded. Okay, let's look at problem number 3. So what we're looking at here is the absolute value of negative 4 minus 7x is less than or equal to 10. So again, for a less than or equal to, you're setting up a compound inequality with and. And again, you can write this as a three-part inequality to make it quicker. So let's take the expression inside of the absolute value bars. I'll put negative 4 minus 7x like this. And we'll say that it's greater than or equal to negative 10, and then it's less than or equal to positive 10. Now from here, I want to first isolate this negative 7x. So let's add 4 to each part here. And let's see where that gets us. This is, of course, going to cancel. So I'm going to have this negative 7x in the middle. And I'll say this is greater than or equal to negative 10 plus 4 is going to be negative 6. And we'll say, and it's less than or equal to 10 plus 4 is going to be positive 14. So from here, I want to get x by itself. So let's divide each part by negative 7. And remember, if you divide by a negative and you're working with an inequality, you have to flip the direction of the inequality symbols. So what we're going to do here is say that this is 6 over 7, so positive 6 over 7. This is now going to be a greater than or equal to here. This would cancel. You would have x. This would be a greater than or equal to here. 14 divided by negative 7 is negative 2. Now what I would do is rewrite this guy in the order of the number line. So negative 2 is to the left of 6/7 on the number line. So it should be when we write our inequality. So I'm going to put negative 2, and I'll put this is less than or equal to x, which is less than or equal to 6/7. Okay, so for our interval notation, both of these guys would be included. So let me just put a bracket here. I'll put my negative 2, comma. I'll put my 6/7 here, and I'll put a bracket. So again, both are included. Graphically, I'll just say this notch here is negative 2, and I'll say this notch here is 6/7. And I'll put a bracket here, and I'll put a bracket here. And then let's just shade everything in between. Again, this is just telling us that x can be any value from negative 2 and including negative 2 up to and including 6/7. All right, let's look at problem number 4. So here we have the absolute value of 5x minus 10 is less than 5. So again, same situation as the last problem. What I'm going to do is take my expression inside the absolute value bars, so the 5x minus 10, and I'll say that this is greater than negative 5 and less than positive 5. And again, very easy to solve this. I'm just going to add 10 to each part here just to isolate the 5x to get things started. And so, of course, this would cancel. You'll have 5x is greater than negative 5 plus 10 is going to be positive 5. We'll say and it's less than 5 plus 10 is going to be 15. So from here, let's divide each part by 5 so that we can isolate x in the middle. And of course, this is going to cancel here. So let's show that as canceling. And we'll have x is greater than 5 divided by 5 is 1. We'll say and it's going to be less than 15 divided by 5 is 3. Okay, so x is greater than 1 and less than 3. In interval notation, let's put a 1 here and a 3 here. Again, with a parenthesis next to each because they're not included. And let's just mark this notch as 1. We'll say this notch is 3. And what I'll do here is just put a parenthesis here at 1, and I'll put a parenthesis here at 3 as well. And again, I'm just going to shade everything in between. So x here can be any value between 1 and 3, with 1 and 3 being excluded. All right, let's look at problem number 5. So here we have the absolute value of 6 minus 3x is greater than 3. So again, since we have the absolute value operation isolated, and we have a greater than, we're now going to go back to a compound inequality with or. So I'm going to have 6 minus 3x is greater than 3, or I'm going to have 6 minus 3x. Remember, flip the sign, so it's less than. Change this to negative, so it's negative 3. So let's subtract 6 away from each side of the inequality here, and let's cancel this. We'll say negative 3x is going to be greater than 3 minus 6 is going to be negative 3. And let's divide both sides of our inequality by negative 3. Remember, this requires us to flip the direction. Right now it's a greater than, so it's going to become a less than. This would cancel. So I have x is less than negative 3 divided by negative 3 is positive 1. Okay, so the first part is done. X is less than 1. Let's go over here and work on this part now. So I'll say subtract 6 away from each side of the inequality. And of course, this would cancel. You'll have negative 3x is less than negative 3 minus 6 would be negative 9. Let's now divide each side of the inequality by negative 3. And of course, if we're dividing by a negative, we have to flip the direction of the inequality symbol. So this will now be a greater than. This will cancel. And so what I'm going to have here is that x is greater than negative 9 divided by negative 3 is positive 3. So our solution is x can be any number that's less than 1, or x can be any number that's greater than 3. So in interval notation, we would say from negative infinity up to but excluding 1. So let's put a parenthesis there to exclude 1, put a parenthesis there. We'll make our union symbol, and then we'll have our 3 out to positive infinity. Again, I'm going to exclude that with a parenthesis, and then I always use a parenthesis with infinity or negative infinity. Now, graphically, I'm just going to really match this, and basically I'm going to put a parenthesis here, right there, and I'll say that this is positive 1, and I'll shade everything to the left here. And then over here, I'll say this is positive 3. I'll put a parenthesis there, and I'll just shade everything to the right. So again, all we're saying is that x can be any number that is less than 1, or it could be any number that is greater than 3. Okay, let's look at problem number 6. So these are going to start to get more involved now, so more steps. So here we have 8 times the absolute value of 3x plus 4, then minus 1. This is less than or equal to 55. All right, so in all the previous problems, the absolute value operation was already isolated for us. So we have the absolute value of some expression, and then we had either a greater than or equal to, a less than or equal to, but then on the right-hand side, we had some number. So that's the form we want to get this into first before we do anything else. So if I want to isolate this right here, then what I would do is I would first think about, well, I have this minus 1 here that I need to get rid of. So let's add 1 to both sides of the inequality. And this would cancel. And what we'd have is 8 multiplied by the absolute value of 3x plus 4. And this will be less than or equal to 55 plus 1 would be 56. Now from here, you see that 8 is multiplying what I want to isolate. Again, my goal is to get this on one side by itself. So what I can do is I can just divide both sides of the inequality by 8. And we know that this guy right here is going to cancel. And what we're going to have is the absolute value of 3x plus 4. And this is now going to be less than or equal to 56 divided by 8 is going to be positive 7. So now we have this into the form of something we know how to solve. Because this is a less than or equal to, we're thinking about a compound inequality with and so we can just use our 3-part inequality format. I'm going to put this guy in the middle, so 3x plus 4. It will be greater than or equal to the negative of this number, so negative 7, and it will be less than or equal to this positive 7. So let's solve this by first isolating the 3x part right there. So I'm going to subtract 4 away from each part here, and let's cancel this. And now we'll say that 3x is greater than or equal to negative 7 minus 4 would be negative 11. And then this is less than or equal to 7 minus 4 is going to be positive 3.
So let's finish this up by dividing each part here by 3. And what that's going to do is isolate x in the middle. So I'll say x is greater than or equal to negative 11 over 3. Can't simplify that at all. And I'll say and it's less than or equal to 3 divided by 3 is 1. Okay, so in interval notation, what I would want to do here is put a bracket and then my negative 11 thirds, then comma, my positive 1, and then a bracket. Right? Each of those numbers are going to be included. So again, we match this format when we graph. Let's say this notch is negative 11 thirds. Let's say this notch is positive 1. And then again, let me change back to orange. And I'm just going to put a bracket here. I'm going to put a bracket here. And I'm going to shade everything in between. So x can be any value starting from negative 11 thirds and including negative 11 thirds up to and including positive 1. Okay, let's think about number 7 now. So we have the absolute value of 3 plus 10x minus 6 is less than or equal to 41. So remember, we need to isolate the absolute value operation on one side. Right now we have this minus 6 that's being done to it. So let's add 6 to both sides of the inequality, and this would cancel. And what we'll have here on the left is the absolute value of 3 plus 10x, and this is less than or equal to 41 plus 6 is 47. All right, so again, we have a less than or equal to, so we know we're going to use a compound inequality with and, or set this up as a 3-part inequality. So I'm going to do 3 plus 10x here, and we'll say this is greater than or equal to, I'll put the negative 47 here, and we'll say and it's less than or equal to positive 47. Now what I want to do is isolate this first. So let's subtract 3 away from each part of the inequality, and let's cancel this. So what is negative 47 minus 3? That's going to be negative 50. We'll say this is less than or equal to, we have this 10x here, which is less than or equal to, 47 minus 3 is going to be 44. And so now, as a final step, let's divide each part here by 10. And that's going to completely isolate x for me. So this would cancel. And what I'd have here is that x is greater than or equal to, negative 50 divided by 10 is going to be negative 5. We'll say and it's less than or equal to, you have 44 over 10. Let me write 44 as 22 times 2. And let me write 10 as 5 times 2. And we see that we have a common factor of 2. So let's cancel that out. We'll say this is 22 fifths over here. So basically, x is greater than or equal to negative 5, and it's less than or equal to 22 fifths. Okay, so in interval notation, let's put a bracket here. Let's put a negative 5. Let's put a comma. Let's put our 22 fifths like this, and let's put a bracket. So each of these guys is going to be included. Let's put a negative 5 here at this notch, and let's put a 22 fifths here at this notch. And let's put a bracket here, and let's put a bracket here. And again, let's just shade everything in between. So x can be any number, starting with negative 5 and including negative 5, going up to and including this 22 fifths. Okay, let's look at problem number 8. So here we have 7 times the absolute value of 8x plus 10, then minus 3. This is greater than or equal to negative 45. So what we want to do again is isolate the absolute value operation on one side. So first I would add 3 to both sides. So let me add 3 here and also here. So to both sides of the inequality, this would cancel. And then over here on the left, I'll have 7 times the absolute value of 8x plus 10. This will be greater than or equal to negative 45 plus 3 is going to be negative 42. Now let's slide down here. We still need to get rid of the 7 that is multiplying this guy. So what I can do is I can divide both sides of the inequality by 7. And we'll cancel this with this. And we'll say the absolute value of 8x plus 10 is greater than or equal to negative 42 divided by 7 would be negative 6. Okay, now let's stop for a minute. We have the absolute value operation isolated on one side, and we have a negative value on the other. So we know if this was an equation, there would be no solution, right? Because there's no possible way that the absolute value operation can give me something that's negative. But in this particular case, we don't have an equation. We have an inequality. So we need to use some simple reasoning here to get our solution. It's not true that this guy right here could ever be equal to negative 6. So this part would never work. But could it be greater than negative 6? Yes, it always would be greater than negative 6 because the result of this would be non-negative, right? So the absolute value of some number or some expression, let's just call it a, is always greater than or equal to 0. Okay, so this would be 0 or some positive value, and 0 or some positive value is always greater than some negative value. So what I can say here for this solution is that it's all real numbers. So all real numbers, right? Anything I want to plug in for x, as long as it's a real number, basically it will work. All right, so we can actually notate this in interval notation just by putting a negative infinity here on the left and then a positive infinity here on the right. And then we can show this graphically by just shading the entire number line. It really doesn't matter for these notches. I'm just going to put -1 and +1. Again, you can put whatever you want, or you can put nothing. You're just going to shade the entire number line just to show that every single real number would be included in your solution set. All right, let's look at problem number 9. So we have the negative of the absolute value of 7x minus 8, then plus 2. We're saying this is less than or equal to -32. So I just want to warn you in advance, just because we see a negative here on one side of the inequality, that doesn't mean that we're going to have a special case scenario. Always go through your steps and isolate the absolute value operation on one side and have a single number on the other, okay, before you make any decision about that. So here, if I want to isolate this guy right here, what I would do is I would first get rid of this plus 2 here. And to do that, I'm just going to subtract 2 away from each side of the inequality. So this would cancel. And what I'm going to have here on the left side, instead of a negative, I'm just going to put a -1. So this is more clear. Then times the absolute value of 7x minus 8, like this. Let me make this 8 better here. And then we'll say is less than or equal to -32 minus 2 is going to be -34. And then from here, let me get rid of this -1 that is multiplying this absolute value operation. So let's divide both sides by -1. Of course, you could multiply both sides by -1. It's whatever you want to do. You're going to have to flip the direction of this either way because we're multiplying or dividing by a negative number and we're working with an inequality. So this is going to be a greater than or equal to now. This over here is just going to cancel out. So we have the absolute value of 7x minus 8 is going to be greater than or equal to -34 divided by -1 is going to be +34. Okay, so from here, we see that we have a greater than or equal to. So we're going to set up a compound inequality with or. So I'm going to first say that 7x minus 8 is greater than or equal to 34. Let me make this 34 better. And then we'll say or. We'll say 7x minus 8 is less than or equal to -34. So we're just going to solve this guy. And let me start out here on the left. Let me add 8 to both sides of the inequality here. So you would have this cancel. 7x is greater than or equal to 34 plus 8 is going to be 42. If we divide both sides of the inequality by 7, this would cancel. You get x is greater than or equal to 6. Now over here, let me add 8 to both sides of the inequality. This would cancel. You have 7x is less than or equal to -34 plus 8 would be -26. And let's divide both sides of the inequality by 7. This would cancel. And so you're going to have x is less than or equal to -26 over 7. So let me write this as x is less than or equal to -26 over 7. You can't simplify that. 7's a prime number. And then I'll say or x is greater than or equal to +6. So in interval notation, I want to first say that from negative infinity coming up to and including this -26 over 7. So I'm going to put a bracket there because it's included. And then again, you want your union. So the union with this other guy. So we're going to start here with +6. That's the smallest value that it can be, and it's included. So we have the bracket, and then out to positive infinity, like this. So then on this guy right here, let's say this is -26 over 7. Let me move this out of the way and just drag this over here. And let's say this is +6 here. Let me grab like an orange. So I'm going to put a bracket here that faces to the left. So it could be -26/7, or it could be anything going to the left out to negative infinity. It could be +6 over here. So let me put a bracket there, and then let me shade everything to the right. So again, this is going out to positive infinity. Okay, let's look at the last problem here, problem number 10. So we have -6 times the absolute value of 7 minus 6x, then plus 2, and this is greater than or equal to 68. So again, I want to first isolate this guy right here. So what I'm going to do, since I have this plus 2 over here, let me subtract 2 away from each side of the inequality. This is going to cancel. We'll have -6 times the absolute value of 7 minus 6x. This will be greater than or equal to 68 minus 2 would be 66. So from here, I've got to get rid of this -6 that is multiplying this guy. So let's divide both sides of the inequality by -6, just like this. So this is going to cancel. And remember, if you divide both sides by a negative, you have to flip the direction of the inequality symbol. So let me write the absolute value of 7 minus 6x here. Instead of a greater than or equal to, this is going to be a less than or equal to. And then 66 divided by -6 is going to be -11. Now, let's pause here for a moment. We saw earlier that if we had the absolute value operation isolated and we had a greater than or equal to or greater than, and you had a negative on the other side, well, then the solution was all real numbers. Because no matter what you plugged in for x, once you go through all the operations and take the absolute value, you're always going to get something that is 0 or positive, and that's always, always, always going to be greater than some negative value. Well, here you have a less than or equal to. It's not going to be equal, and it's not going to be less than. It's not possible. Because again, the result of this is either 0 or some positive value, so that can never be less than a negative, and it can never be equal to a negative. So for this type of problem, there is actually no solution. Okay, so no solution. Again, some people like to write the symbol for the null or empty set, and once again, we'll get to that later on in the course. Let's take a look at our practice test. We're told to solve each inequality, write in interval notation, and graph. We're going to look at problem number 1 first. So we have the absolute value of x minus 3. This is greater than the absolute value of 2x minus 5. So let's actually take this down to a little table, and we'll work on it there. And I'll show you how to set this up based on the interval that you're in. Okay, so the first thing is if you're going to solve this type of inequality, you need to consider a rule for when you're going to drop the absolute value bars. In other words, you would think about, is this guy inside of the absolute value bars, that expression, is it negative, is it 0, or is it positive? If it's negative, then you need the negative of that expression in that interval. If it's 0 or positive, you can just drop the absolute value bars. So you would say, where is this 0? So where is x minus 3 equal to 0? Well, you just add 3 to both sides of the equation, cancel that, you get x is equal to 3. So that's going to be one, what we call breakpoint. Okay, I'm just going to keep this here for right now. I'll fill in the table in a second. We need the other one. So let's look at this one. So this is 2x minus 5. So let's say 2x minus 5 is equal to 0. We'll add 5 to both sides of the equation. We'll cancel that. We'll say 2x is equal to 5. Divide both sides by 2. So you get x is equal to 5 halves. Let me just get rid of all this and write this more neatly. So x is equal to 5 halves. So you're going to use these two numbers to set up intervals on the number line. You first think about the leftmost value. So if I'm on the number line, 2.5 is to the left of 3. So what I'm going to do is first have my leftmost interval, I'll say coming from negative infinity, going up to and excluding 5 halves. Now, a lot of people get confused here when you start including or excluding things. So I'm just going to set this up, and then I'm going to talk about why. So the next interval, if you look at it, it's going to be between these two values. So 5 halves and 3. But I'm going to actually include 5 halves here, and I'm going to exclude 3. And again, I'll talk more about this in a moment. And then the next interval would be anything that includes 3 and going out to positive infinity. So basically 3 or anything greater. So now we've basically split up our number line into 3 intervals. So anything that's strictly less than 5 halves, anything that's between 5 halves and 3, where 5 halves is included, and then anything that's 3 or larger. Now, what you're going to do is go through and think about in this interval here, where x is less than 5 halves, well, each one of these guys is going to be negative. So basically, instead of the x minus 3 here, when I drop the absolute value bars, I want the negative of the quantity x minus 3. And then when I drop the absolute value bars here, I want the negative of the quantity 2x minus 5. So that's going to be our rule in this interval. When we get into this interval here, you think about 5 halves itself. The reason it's included here is because 5 halves would make this guy, this expression, 0. So whether it's 0 or some positive value, you can just drop the absolute value bars. So this one right here would be 2x minus 5. And then in this interval, it's going to be positive, so it's just 2x minus 5. Okay, so if it's 0 or positive, just drop the absolute value bars. Now, in this interval here, this guy is still going to be negative. It's going to be 0 when it's 3, so that's not till here. So here it's negative, right, because we're less than 3. So we're going to say that this is the negative of this quantity x minus 3. Okay, now in this final interval, again, this guy right here starts at 3 and it includes 3. So this guy could be 0 or it's anything greater where this guy would be positive. So again, whether it's 0 or positive, just drop the absolute value bars. So this is just x minus 3. So one thing I want to touch on, if you worked on this with me where we solved equations, you saw that I actually excluded this. So I excluded 5 halves and I excluded 3. Now, I'm not going to do that in this situation because when you work with inequalities, you often have this overlap, and you're going to see that in this problem. So I think in this situation, this is better.
although you could still make it work with this one. I think it's a little bit more challenging to think about it that way, so I'm just going to just work with it this way for this type of problem. Let's start out in the leftmost interval, or where x is less than 5/2. So again, I'm going to basically replace this guy right here with this guy right here. So I want the negative of the quantity x minus 3. That's my rule for dropping the absolute value bars there. Then this is greater than, I want to replace this guy right here with this guy right here. So the negative of the quantity 2x minus 5. So let's come down here. We'll go back up in a minute. So just distributing the negative, this is negative x and then plus 3. This is greater than, this is negative 2x, and this is plus 5. What I'm going to do first is add 2x to both sides of our inequality here. This is going to cancel. And then I'm going to subtract 3 away from each side of the inequality here. This is going to cancel. So negative x plus 2x is going to be x, and this is greater than 5 minus 3 is going to be 2. So here we have that x is greater than 2. So I want to think about that with you. Let's erase everything first. So the way this works, when you get a solution, you come into your interval. Let's just write x is greater than 2 here. And you would say, is this in this interval? So if I think about 5/2, that's 2.5. If I said that x is greater than 2, what I would have here is a partial solution, right? Because it has to be in the interval. So basically, x would be greater than 2, but it would also have to be less than 5/2 because you have that cutoff there. So we're going to replace this and say that x is greater than 2 and less than 5/2 so that we can stay in this interval. Now, I move on to the next interval and I think about what we have here. To replace this guy right here, I'm going to use this guy right here. So this is the negative of the quantity x minus 3. And this is greater than. To replace this, I'm going to use this one. So it's just going to be 2x minus 5. Okay, so this right here is going to be negative x and then plus 3. And this is greater than 2x minus 5. So here I'm going to subtract 2x away from each side of the inequality. This would cancel. Let's subtract 3 away from each side of the inequality. This is going to cancel. So we'll come up here. Negative x minus 2x is going to be negative 3x. This is greater than, negative 5 minus 3 is going to be negative 8. What I'll do from here is divide both sides of the inequality by negative 3. This will cancel. We'll get x is, remember this has to get flipped here because we divided by a negative. So this is less than, negative over negative is positive. This is going to be 8/3. Now is this in this interval? Well, yes. 8/3 is going to be 2 2/3. So that is, if you think about 5/2, that's 2.5. That is a larger value than 2.5, and it is a smaller value than 3. So we're good to go there. But what you have to consider, again, is if you're going down to the left, you have to stop at this 5/2. Now, you would include 5/2 here because it's included. So what you would do is you would say that x is greater than or equal to this 5/2 and less than, and this is going to be strictly less than, this 8/3. So you can see that we're going to be able to merge these two, and we'll talk more about that in a moment. Now let's work on this last interval here. So here, everything is going to be non-negative. So this is 0 or positive, and this guy right here would be positive, right? So I can just drop the absolute value bars and just solve x minus 3 is greater than 2x minus 5. So what we'll do is add 3 to both sides of our inequality. We'll cancel this. We're going to subtract 2x away from each side of the inequality. Let's cancel this. X minus 2x is negative x. This is greater than, negative 5 plus 3 is negative 2. Let's divide both sides by negative 1. So this is going to get flipped. This is a less than. So here we basically have x is less than, negative 2 over negative 1 is 2. So we have x is less than 2. Okay, is this in this interval? No, this guy has a smallest value of 3, 3 is included, or anything larger, right? This is x is less than 2. This is not in this interval. So basically you just reject that solution, right? You don't even consider it. So now what we want to do, I'm actually just going to erase this so I have enough room. You're going to take these two guys and you're basically going to merge them with the keyword or. Okay, so you're going to say that x is greater than 2 and less than 5/2, then or. You're going to say x is greater than or equal to 5/2 and less than 8/3. Now, if you think about this, this is basically where x is going to be greater than 2 and less than 8/3, which is this 2 2/3, right? Because the 5/2 is actually included here, okay, even though it's excluded here. So that's how that works. So what I'll do is say that my final answer is x is greater than 2 and it's going to be less than 8/3. So let's grab this. Now, typically when you solve this type of problem, they're going to ask you to write the solution in interval notation. So let's put a parenthesis next to 2 because it's not included. And let's put a parenthesis next to 8/3 because it's not included. All right, now in terms of graphing this, let's put a 2 here and then an 8/3 here. And then I'm going to use a parenthesis at 2 to show that it's excluded, and a parenthesis at 8/3 to show that it's excluded. Again, you can always use an open circle. Your book may do that instead. So let's shade this in. So basically we're showing that x can be anything that's larger than 2, going up to and excluding 8/3. All right, so if you're struggling with this concept, you can always graph this using a free online graphing calculator. I would recommend something like Desmos. I'm using MathGV, which is something that's also free. So let's first think about what we had. We had the absolute value of x minus 3, and we said this is greater than the absolute value of 2x minus 5. Now, we haven't talked too much about graphing in this course yet, but hopefully you remember some of this stuff from Algebra 1. Essentially, this guy in green, this is y is equal to the absolute value of x minus 3. This guy in purple, this is going to be y is equal to the absolute value of 2x minus 5. So you're just looking at the graph of each and you're saying, hey, where is this green graph above this purple graph, right? So you can see here it's below, 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 below. And you'll see that at 2, they're going to intersect. And they're also going to intersect. This is going to be that 8/3 that we talked about, or the 2 2/3. And then everywhere outside of that, it's going to be below. So you can see that this piece right here, between this 2 and 8/3, it's actually going to be above the purple graph, where it has a higher y value or function value for those given x values. So that is true where x is greater than 2 and less than 8/3. Again, at 2 and 8/3, they're equal. So this is a strict inequality, so you have to use strict inequalities here. So that's how you could get your solution graphically. All right, let's take a look at problem number 2 now. So we have the absolute value of 3x minus 4 is greater than the absolute value of x minus 2. So let's just write that really quickly. So again, the absolute value of 3x minus 4 is greater than the absolute value of x minus 2. Okay, so once again, I'm going to work on a table. If you want to use a number line, that's fine. But we're just going to split this into different intervals. Now, we get the intervals from, again, thinking about what's inside of the absolute value bars. You're going to set that equal to 0. So, for example, here, 3x minus 4, if I set that equal to 0, we add 4 to both sides. Cancel this. You get 3x is equal to 4. Divide both sides by 3. We'll cancel that. So x is 4/3. So let me just put x equals 4/3. And this is just scratch work. I'm going to erase that in a moment. The other guy is this x minus 2. So x minus 2 equals 0. Add 2 to both sides. And you get x is equal to 2. So you're using these two numbers here to split the number line up into 3 intervals. Okay, so you think about the leftmost value. The leftmost value here is 4/3, right? It's 1 1/3, that's less than 2. So you're going to create this interval here coming from negative infinity and going up to and excluding this value. So excluding 4/3. You want something where both of these are going to be negative. You don't want to include 4/3 because this would make this 0. Okay, so they both have to be negative in this first guy. Then here, this is going to be between these two values, but I'm going to include 4/3 and I'm going to exclude 2. And the reason I'm doing that is if I include 4/3 for this one, it's 0, and that's okay. Because if this guy is 0 or some positive value, it's the same rule. I can just drop the absolute value bars. But I don't want to include 2 here, because if I did, well then here at 2, this is 0. It's a different rule than if it was negative or less than 2. So the last interval would include 2 and go out to positive infinity. Okay, so we've split the number line up into these 3 intervals. So what we are basically doing is just getting a rule for dropping the absolute value bars in each interval. So in the leftmost interval where we're strictly less than 4/3, this expression is negative and this expression is negative. We know that. So basically you replace this guy right here with the negative of the quantity 3x minus 4. You replace this guy right here with the negative of the quantity x minus 2. Now, when we move to the right in this next interval, 4/3 is included. So that makes this guy 0 here. And then we're going up to but excluding 2. So between 4/3 and including 4/3 and 2, this guy is either 0 or positive. And whether it's 0 or positive, you just drop the absolute value bars. So it's just 3x minus 4. Then when we get to 2 or larger, it's going to be positive, right? So it's 3x minus 4 here as well. So then when we think about this x minus 2 here, this is negative in this interval, okay? And that's because we're less than 2. That's why we didn't include it here. So this is the negative of the quantity x minus 2. And then here, because we're including 2, it can be 0 or anything larger where it would be positive.
So for that, if it's 0 or positive, just drop the absolute value bars. So this is x minus 2. Okay, so this gives us our setup. And once we've done all this work, we just go through and set up our inequality in each interval, see if it fits in the interval. If it does, we can accept it. If it doesn't, we can reject it. And then at the end, we're going to think about everything together and try to merge. So we're going to think about this first guy where both of these are negative. So I want the negative of the quantity 3x minus 4. And this is going to be greater than the negative of the quantity x minus 2. So here you could distribute the negative into each, or you could just divide both sides by -1 and flip the direction of this. Again, that doesn't really matter, but this would cancel, and you would have 3x minus 4. I'm going to flip this to a less than, and this is x minus 2. Maybe that's quicker, maybe it's not. It just depends. Let me show this as canceling so nobody's lost. So from here, I'm just going to subtract x away from each side of the inequality, and I'm going to add 4 to both sides of the inequality. So let's show this is canceling and this is canceling. If we think about 3x minus x, that's 2x, and this is less than. -2 plus 4 is +2. We'll divide both sides of the inequality by 2. That will cancel. You'll get x is less than 2 over 2 is 1. So we get x is less than 1. So coming back up and thinking about this interval is x is less than 4/3. So that's 1 1/3. If I put x is less than 1, that's in that interval. So you don't have to do anything there at all. So for this next one, this guy is going to basically be either 0 or positive. So we just drop the absolute value bars. And then this guy right here is going to be negative. So I want the negative of the quantity x minus 2. So let's go 3x minus 4 is greater than, you can just distribute this now. This is the negative of x and then plus 2. We will say that we'll add x to both sides of our inequality, add 4 to both sides of our inequality. And so this cancels and this cancels. 3x plus x is 4x. And this is greater than 2 plus 4 is going to be 6. Let's divide both sides of the inequality by 4. So this is going to cancel. And we have x is greater than. For 6 and 4, they're each divisible by 2. 6 divided by 2 is going to be 3. And 4 divided by 2 is going to be 2. So you get x is greater than 3/2. So let's put x is greater than 3/2. But there's an issue here. You can't just have x is greater than 3/2 because it has to be in this interval. Now, 3/2 is greater than 4/3, right? 4/3 is 1 1/3. 3/2 is 1.5. You would just want to adjust it to cut it off to stay in the interval. So you would say that x is greater than 3/2, and you have to say that it's less than 2 because you have to stay in this interval. Now, again, you might get something over here that works. I'm going to tell you in advance you do. So you're going to end up including 2, but we're not going to do it just yet because we're not there yet. Now, over here, everything is non-negative. For this one, it's 0 or some positive value. For this one, it's positive. So in each case, you can just drop the absolute value bars. So you would have 3x minus 4 is greater than x minus 2. Let's subtract x away from each side of the inequality. Let's add 4 to both sides of the inequality. Let's cancel this and cancel this. And we'll say that 3x minus x is 2x. And this is greater than -2 plus 4 is going to be 2. Let's divide both sides of the inequality by 2. We'll cancel this and say x is greater than 2 over 2 is 1. Okay, so let's come back up here. And I'm going to write x is greater than 1. Now we have to be in our interval, and remember the smallest value here in the interval is 2. So I'm just going to adjust my solution to account for that and say here x is greater than or equal to 2. Okay, so now we're ready to put everything together. Let's get rid of this. We don't need it anymore. And you're going to put everything together with the keyword or. So you're going to say that x is less than 1, then or. You're going to say that x is greater than 3/2 and less than 2. Then you're going to say or x is greater than or equal to 2. Now, this part right here on the left is straightforward. X is less than 1. Nobody's going to get lost on that. But this part right here, I think, would trip a lot of people up. So let's spend some time on it. And basically, you want to think about the fact that here, x is greater than 3/2. So let me start by just writing that. So x is greater than 3/2. Then you say and less than 2. Okay, but then you have the keyword or here, and you're saying x can be 2 or anything larger. So really, it's kind of like you can get rid of this part from this statement here. And if you considered x is greater than 3/2 or x is greater than or equal to 2, well, then it's just x is greater than 3/2. So you can actually just get rid of this altogether and write your solution as x is less than 1 or x is greater than 3/2. And I know that was confusing, but you might need to just pause the video, really think about what's going on. You can draw this out on a number line and consider everything. So let's grab this. So I'll say, coming up from -infinity and going up to but excluding 1. So make sure you use a parenthesis with 1. And then it's the union with, you're going to use a parenthesis with 3/2 because it's not included. So anything larger than that, so that's going to go out to positive infinity. So graphically, you could find 1 on the number line. I'm just going to put a 1 here, and then 3/2. I'll just put the 3/2 here. And then basically, I'm going to use a parenthesis with 1, and then I'm going to shade everything to the left here. And then I'm going to use a parenthesis with 3/2, and I'm going to shade everything to the right here. And remember, you can always use an open circle instead of a parenthesis if that's what your book does. So we can see graphically that x can be anything that is less than 1, or x can be anything that's greater than 3/2. All right, so once again, if you're struggling with these types of problems, you can graph them, use Desmos. We had the problem where we said the absolute value of 3x minus 4 is greater than the absolute value of x minus 2. So graphically, we could say this guy in green is y is equal to the absolute value of 3x minus 4. And this guy in purple, we could say this is y is equal to the absolute value of x minus 2. So basically what we're saying is where is the green graph, or again, the graph of y equals the absolute value of 3x minus 4, where is that above the purple graph, or the graph of y equals the absolute value of x minus 2? We can see where they cross, and that's going to be important. So we have this 1 right here in terms of this x value. That's where the y values or the function values would be equal. And then also you have this other crossing point. This is going to be 3/2. Remember, we saw that. Everywhere to the left of 1 in terms of the x value, this green graph is above this purple graph. We can all see that. And everywhere to the right of this 3/2 in terms of the x value, the green graph is again above the purple graph. So graphically, we can say the solution is x is less than 1, or x is greater than 3/2. Okay? If this guy had been flipped and it was a less than, well, then you're talking about this piece in between, right? So there it would be that x is greater than 1 and less than 3/2. So again, really easy to see what's going on when you graph these guys. I strongly suggest this if you're struggling with these problems. All right, let's move on now and look at problem number 3. So we have x plus 3 is greater than or equal to, we have the absolute value of 2x minus 3, and then plus 1. So with this one, we don't have two absolute value operations. We only have one. So it's going to make it a little bit easier. Let's just copy the problem. So we have x plus 3 is greater than or equal to the absolute value of 2x minus 3, and then plus 1. Now, because we have this x here that's outside of the absolute value bars over here, we still have to do a little bit more work. So we have a table here, but it's just going to be 2 intervals. Okay, so we don't need 3 intervals here. So you're just going to consider, now let me unhighlight this so nobody gets confused. You're just going to consider where 2x minus 3 is equal to 0. And then basically, let's set that up. So 2x minus 3 is equal to 0. Let's add 3 to both sides. Let me make that 3 a little bit better. We'll cancel this. We get 2x is equal to 3. Divide both sides by 2. We get x is equal to 3/2. So we know if x is less than 3/2, so basically coming from negative infinity, going up to but excluding 3/2, that this guy right here, this expression is going to be negative. So we want the negative of the quantity 2x minus 3. So that's the rule if we drop the absolute value bars. Now, anything where we are at 3/2 or greater, well, this guy would be 0 or some positive value, so we could just drop the absolute value bars. So I'm going to include 3/2 here and go out to positive infinity. And so here it would just be 2x minus 3. So we have our rule, and we just have to solve 2 inequalities. So let's see with the first one. I have x plus 3 is greater than or equal to. We'll replace this guy with this guy. So I have the negative of the quantity 2x minus 3. And then basically we have plus 1. Okay, so we have x plus 3 is greater than or equal to. Let's go the negative of 2x, and then plus 3, and then plus 1. Now you notice that you have 3 here and 3 here. You could subtract 3 away from each side of the inequality. Let me actually just show that so that nobody is lost. And I'll cancel it like this so it's a little bit more clear what's going on. Okay, from here I'm going to add 2x to both sides of the inequality. And I'll cancel this. And so what do we have left? We have x plus 2x, that's 3x. This is greater than or equal to 1. We'll divide both sides of the inequality by 3. This will cancel, and you get x is greater than or equal to 1/3. So let's put that x is greater than or equal to 1/3. Is that in our interval? Well, remember, the interval is basically going to be anything that's less than 3/2. So 1/3 would be in this interval. The only problem is, when you write it, you want to stop at anything that's less than 3/2. So you would say that x is greater than or equal to 1/3 and less than 3/2. So that's what we want to do there. Okay, for the next guy here, you're just going to drop the absolute value bars. So I'm just going to get rid of this and solve this inequality and see what that gives us. So here I will subtract 2x away from each side of the inequality. Cancel this. Let's subtract 3 away from each side. And so this would cancel, and we'll say x minus 2x is negative x. This is greater than or equal to. You basically have negative 3 minus 3, which is negative 6, and then plus 1, that's going to be negative 5. Let's divide both sides of the inequality by negative 1. So this cancels. We're going to flip this because we divided by a negative, so this is a less than or equal to. Let me write my x in there, and negative 5 over negative 1 is 5. So you get x is less than or equal to 5. So let's write in here that x is less than or equal to 5. Now, again, you have to consider that this interval is going to start at 3/2. So I'm going to basically rewrite this and say that x is greater than or equal to 3/2 and less than or equal to 5. So if you put these two together, you're basically saying that x is greater than or equal to 1/3 and less than 3/2, then or x is greater than or equal to 3/2 and less than or equal to 5. Well, this guy right here includes the 3/2, right? So 3/2 is included. So basically, if you put these together, you would say that x is greater than or equal to 1/3 and less than or equal to 5. Okay, so let's just get rid of this, and I'll just slide this down. So that would be your answer. So x is greater than or equal to 1/3 and less than or equal to 5. So in interval notation, we're going to put a bracket next to 1/3 because it's included. And then I'm going to put a bracket next to 5 because it's included. So basically, it's between 1/3 and 5 where both are included. That's all we're saying. Let me put a 1/3 here and a 5 here. And so I'm going to put a bracket here at 1/3 to show it's included, and a bracket here at 5 to show that it's included. Again, if you want to use a filled-in circle, if your book does that, that's fine. It means the same thing. And so I'm just going to shade everything in between. So x here graphically can be 1/3 or anything going up to and including 5. All right, so once again, you can look at this graphically. So you're going to graph this guy in green here. This is just a simple linear equation in two variables. This is y is equal to x plus 3. A lot of us know how to graph that already. So the y-intercept is at 0, 3, and the slope is 1, right? So go up 1 to the right 1, so on and so forth. Then this other part here, the part on the right, this is this guy in purple. This is y equals the absolute value of 2x minus 3, and then plus 1. Okay, so if you don't know how to graph this, again, you can just use a computer-generated graph for right now. We'll talk about how to graph this stuff later on in the course. But I just want you to see that basically I'm asking, where is this guy, this x plus 3, or this y equals x plus 3, or this green graph above or equal to this other guy here, this y equals the absolute value of 2x minus 3 plus 1, this purple graph? Well, you can see they're equal here and here, right? And so this right here, the x value would be 1/3. And this right here, the x value would be 5, right? So that's where they're equal. And then essentially, between those two values, you can see the green guy is going to be above the purple guy, but nowhere else, right? So we could say that the solution graphically is that x is greater than or equal to this 1/3 and less than or equal to 5. So this is exactly what we saw from solving the problem. All right, let's take a look at problem number 4 now. So we have the absolute value of 5x plus 12 is greater than the absolute value of x minus 9, then plus 1. All right, let me copy this. So the absolute value of 5x plus 12 is greater than the absolute value of x minus 9, then plus 1. So again, we're back to having two absolute value operations. So I've got to set this equal to 0 and solve, and set this equal to 0 and solve. So let's go 5x plus 12 is equal to 0. I'll subtract 12 away from each side. I'll cancel that. 5x is equal to negative 12. And so what I'll do here is divide both sides by 5. We'll cancel this and say x is going to be negative 12/5. So I'm just going to write this right here. It's just scratch work. I'll move it in a second. Let me get the other one going. So this is just x minus 9 is equal to 0. And of course, we just add 9 to both sides of the equation. We cancel that and we get x is equal to 9. So the leftmost value here is this negative 12/5. So I'm going to say that coming from negative infinity, going up to and excluding negative 12/5. And then again, here I'm going to include negative 12/5. And we're going to go up to and exclude 9. And then here I'm going to include 9 and then anything larger. All right, so we've got the intervals going. In this leftmost interval, we know both of these guys are going to be negative. So I want the negative of the quantity 5x plus 12. Let me just speed this up and say this is negative 5x minus 12, just so we don't have to deal with that. So let's get rid of this and scooch that up. And then basically in this interval here, this guy is going to be 0 or some positive value. So I can just drop the absolute value bars. So this is 5x plus 12. And then again, here it will be positive. So this is 5x plus 12. Okay. For the other guy, this x minus 9, in this first interval, in the second interval, it's going to be negative. So you want the negative of the quantity x minus 9, which is negative x plus 9. So negative x plus 9, and then negative, let me make that better. So negative x plus 9. Okay, here it's either going to be 9 where it's 0, or it's going to be some positive value. So in that situation, you can just drop the absolute value bars. So it's just x minus 9. Now we just have to go through and solve our inequalities. So for the first interval, I'll just say negative 5x minus 12 is greater than, you'll have this negative x plus 9 and then plus 1. So 9 plus 1 is 10. Let me just replace that now. And so really quickly, I could just add 12 to both sides of the inequality. Let's cancel this. I'm going to add x to both sides of the inequality. Let's cancel this. And let's say negative 5x plus x is negative 4x. This is greater than 10 plus 12 is going to be 22. Let's divide both sides of the inequality by negative 4. We'll cancel this and say x is less than. Let me show this. The reason I flipped this again is because we divided both sides by a negative. And then 22 over negative 4, we know that's negative. 22 divided by 2 is 11, and 4 divided by 2 is 2. So this is negative 11 halves here. So let me grab this. So coming back up here, this guy will be within this interval. If you do negative 12 divided by 5 on your calculator, you get negative 2.4. If you do negative 11 divided by 2 on your calculator, that's negative 5.5. So this solution, we can just accept it. We don't need to modify it in any way. So for this guy right here, we can just say that 5x plus 12, just drop the absolute value bars, is greater than, here I want the negative, so negative x plus 9 and then plus 1. So again, 9 plus 1 is 10, so let me just replace that real quick. And so we'll add x to both sides of the inequality. That cancels. We'll subtract 12 away from each side of the inequality. That cancels. So if you have 5x plus x, that's 6x, and this is greater than, 10 minus 12 is negative 2. Let's divide both sides of the inequality by 6. This will cancel. We get x is greater than, we know this is negative. If you have 2 over 6, each is divisible by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So x is greater than negative 1/3. So we have x is greater than negative 1/3. Now, again, negative 12 divided by 5, that's negative 2.4. If I think about negative 1/3, that is greater than this, so I'm okay there. But again, you can only go up to anything that's less than 9 to stay in this interval. So I'm going to say that x is greater than negative 1/3 and less than 9, just to make that work in the interval. Over here, let's solve this one. So we're going to have 5x plus 12, and then this is greater than your x minus 9, and then plus 1. So we're just dropping the absolute value bars here. So negative 9 plus 1 is going to be negative 8. I'm just going to replace that, and then what I'll do is subtract 12 away from each side of the inequality. That cancels. Let me subtract x away from each side of the inequality. That cancels. So we think about 5x minus x, that's going to be 4x, and this is greater than. Negative 8 minus 12 is going to be negative 20. Let's divide both sides of the inequality by 4. So we're going to cancel this with this and say that x is greater than, we know this is a negative, 20 divided by 4 is 5. So x here is greater than negative 5. So we got a solution of x is greater than negative 5. Now, for this interval, this would only come into play once we got to 9. So we would only think about this as x is greater than or equal to 9, because again, the rest of that is not in this interval. Okay, so we will get rid of this and use this. Okay, so let's put our solution together. And this is where people get confused. Let me erase this so I have some room. So I'm going to start with x is less than negative 11 over 2. That's easy. Then you're going to go or. This is where it gets complicated. So you have x is greater than negative 1/3 and less than 9. Then you have or again. You have x is greater than or equal to 9. So I know this part right here is super confusing for a lot of students. But just pause the video for a moment and just think about it. What's going on here? So this part is simple enough. So x is less than negative 11 over 2. That's easy to understand. But here, I want you to think about the fact that although you have this x is less than 9 here you have x is greater than or equal to 9. So really, you could just get rid of this, right? You could just not think about that. So if I had x was greater than negative 1/3, then or x is greater than or equal to 9, well, again, this is or, so it can work in either. So I'm going to take the least restrictive, right? So I'm going to go with x is greater than negative 1/3. So really, you can get rid of this and just say or x is greater than negative 1/3. And in interval notation, so basically anything coming up from negative infinity going up to but excluding negative 11 halves. I'll use a parenthesis there. And the union with anything that's larger than negative 1/3. So I'll use a parenthesis there. So this is going out to positive infinity. So let's say this is negative 11 halves and this is negative 1/3. And again, I'm going to use a parenthesis to exclude things. You can use an open circle if your book does that. So I'm just going to put a parenthesis here facing to the left, shade to the left, and put a parenthesis here facing to the right, shade to the right. So graphically, x is anything that's less than negative 11 halves or anything that is greater than negative 1/3. All right, so once again, if you're a little bit lost in this problem, you can always graph it. So you're going to take the left side here. This is y equals the absolute value of 5x plus 12. So that's going to be this guy in green. And then the right side here, this is going to be y is equal to the absolute value of x minus 9 and then plus 1. And this graph is cut off a little bit because it's kind of hard to display, but this would keep going up like that. It forms a V shape. But essentially what you look at here, we're saying where is the green graph above the purple graph? You can see where they intersect, so that's going to be here. And if you come down to the x value for that, it's going to be, let's say, negative 5.5 or negative 11 halves. I know that's not perfectly aligned there, but let's just say that's good enough. And then here, this is going to be our negative 1/3. Again, it's not perfectly aligned, but you can see that's where it is. And then basically, you can see that between these two values, the purple graph, or the right side here, is actually above the green graph. But that's not what we want. We want the green graph to be above the purple graph. So that occurs anywhere to the left of negative 11 halves. So again, we found that as x is less than negative 11 halves. And that also occurs anywhere to the right of negative 1/3. So we'd say, or x is greater than negative 1/3. Okay, so this is how you can look at this graphically and make that a little bit better and find your same solution. If you're confused about something, it's always good to stop and look at the graph.
All right, let's take a look at problem number 5 now. So we have the absolute value of 3x minus 5, then minus the absolute value of 2x minus 7. This is greater than or equal to 6. So again, coming to our table, we just want to think about where 3x minus 5 is equal to 0 and where 2x minus 7 is equal to 0. So we'll say 3x minus 5 is equal to 0. We'll add 5 to both sides of the equation. We'll cancel that and say 3x is equal to 5. And then we'll divide both sides of the equation by 3. So we get x is equal to 5/3. Let me get rid of this. And then the other guy, we have 2x minus 7. So we'll say 2x minus 7 is equal to 0. Let's add 7 to both sides and cancel this. We get 2x is equal to 7. Divide both sides by 2. This cancels. And we get x is equal to 7 halves. Okay, so if we think about 5 divided by 3, that's basically 1 2/3. And if I think about 7 halves, that's 3.5. So 5/3 is the smaller value. So let's say this first interval is coming from negative infinity, going up to, and again, excluding the 5/3. Let me make this 5 a little bit better here. Then for the next interval, I will include 5/3, and I'm going to go up to but exclude 7 halves. And then for the final interval, I will include 7 halves, and I will go out to positive infinity. All right, so we already know how this works. In the leftmost interval, they're both negative. So I'm going to want the negative of the quantity 3x minus 5. So I want negative 3x, so negative 3x, and then the negative of negative 5 is plus 5. So all I did was I distributed a negative to each term here. Then this one would also be negative. So let's say this is the negative of 2x, and the negative of negative 7 is going to be plus 7. So this first interval is done. Now in the second interval, we would say that this guy right here would be non-negative, right? If it's 5/3, then it's 0. Any other value would make it positive. So you could just drop the absolute value bars. So this is just 3x minus 5 here. In this interval, this guy's positive. So again, just drop the absolute value bars, same rule. So 3x minus 5. Now for this guy, it's still going to be negative in this interval. So this is negative 2x plus 7. But then once we get here, it's non-negative, right? If it's 7 halves, then it's 0. Anything larger is positive. Again, same rule for that. So just drop the absolute value bars. It's 2x minus 7. All right, let's go ahead and set this up. So in the first interval, we're going to have negative 3x plus 5 in the place of this guy. Then you have this minus here. And this is where you have to be really careful. You have to wrap whatever you're going to put here in parentheses. So I'm going to say minus the quantity negative 2x plus 7, because this whole thing's being subtracted away. Then this is greater than or equal to 6. At this point, I'm just going to say this is negative 3x plus 5. the negative gets distributed to each. So this is plus 2x and then minus 7. This is greater than or equal to 6. So if you have negative 3x plus 2x, that's going to be negative x. And then 5 minus 7 is going to be negative 2. And again, this is greater than or equal to 6. Let's add 2 to both sides of the inequality. Let's cancel this away. We'll say negative x is greater than or equal to 6 plus 2 is going to be 8. If we divide both sides by negative 1, remember to flip the direction of the inequality symbol here. This would give us, this cancels, x is less than or equal to 8 divided by negative 1 is going to be negative 8. So x is less than or equal to negative 8. So coming back up here, we have x is less than or equal to negative 8. And does that fit in this interval? Yes, it does. So we can take this solution. Okay, for the next one, we're in this interval here. So let's think about dropping this and saying we have 3x minus 5. Then minus, you have to be really careful with this minus sign again. You're going to take this and put it in this place. So this would be the quantity negative 2x plus 7. And this is greater than or equal to 6. Let me make this a little bit better here. So we have 3x minus 5. And then the negative of negative 2x is plus 2x. And then the negative of 7 is just minus 7. And this is greater than or equal to 6. So negative 5 minus 7 is negative 12. And 3x plus 2x would be 5x. So this is 5x minus 12 is greater than or equal to 6. Let's add 12 to both sides of the inequality. This cancels. You get 5x is greater than or equal to 6 plus 12 is 18. If we divide both sides of the inequality by 5, this cancels. And you're going to have that x is greater than or equal to 18 fifths. Okay, so let's write x is greater than or equal to 18 fifths. Now, does this work? Well, actually, no. It's not going to be in this interval. You can cross it out. If you divide 18 by 5 on your calculator, you get 3.6. And remember, we're thinking about this 7/2. This is 3.5, right? So this value right here is outside of this interval, so you just reject it. Okay, let's look at this interval here. So in this case, we could just drop the absolute value bars. But again, you have to be really careful with that minus sign. So let's say this is 3x minus 5, and then minus the quantity 2x minus 7, and this is greater than or equal to 6. So we'll have 3x minus 5, and then you'll have minus 2x, and then plus 7, and this is greater than or equal to 6. So here, 3x minus 2x would be x. Negative 5 plus 7 is going to be 2. So let's put plus 2. This is greater than or equal to 6. For this one, let's subtract 2 away from each side of the inequality. This cancels, and we'll say x is greater than or equal to 6 minus 2 is 4. So let's put x is greater than or equal to 4. And this is in my interval, right? This starts with 3.5 or 7/2 and continues out to positive infinity. So I'll just say x is greater than or equal to 4 is something I can accept. Let me get rid of this, and we'll just write our solution. So here it's pretty easy. We just say x is less than or equal to negative 8, or x is greater than or equal to 4. Okay, in interval notation, I'm going to say coming from negative infinity, going up to and including negative 8. So you want a bracket next to negative 8. And then the union with, you want a bracket next to 4 since it's included. And it's going to go out to positive infinity. And then just put a parenthesis there. Okay, so at negative 8, it's going to be included. So I'm going to put a bracket there. Again, you can use a filled in circle if that's what your book does. We're going to shade everything to the left. And then at 4, we're going to put a bracket there, or once again, you could use a filled in circle. And then I'm just going to shade everything to the right. So graphically, x could be negative 8 or anything less, or x could be 4 or anything greater. So this graph right here in green, this is, you could say y is equal to the absolute value of 3x minus 5, then minus the absolute value of 2x minus 7. So you're trying to see where this guy is greater than or equal to 6. So you're looking for a y value of 6, so that's right here. So you come over, I'm just going to see where it intersects. So that's going to be right here, that's an x value of 4. And also going over here, that's going to be an x value of negative 8, right? And that's what we found. So basically at negative 8 or at 4, it's going to be equal to 6. And then anything to the right of 4 in terms of the x values, you can see that you're going to be above 6. So you could say x is greater than or equal to 4. That's that part. And then let me put or here. The other part is, again, if you're at negative 8 or anything less, you're going to be above 6. So let me actually slide this down just a little bit. I'll say also that x is less than or equal to negative 8. So again, that's how you could get your solution graphically. All right, let's take a look at problem number 6 now. So here we have a problem with nested absolute value. So we have the absolute value of, and then the absolute value of 2x minus 1, then plus 3. This is going to be less than or equal to 4. All right, so this one is a bit tricky, and we didn't do a problem like this in our lesson. But remember, in the previous section, we talked about how to solve an absolute value equation of this type. So we're just going to extend that now to working with an inequality of this type. And the idea here is to first think about this guy right here. So I'm just going to say that that's some algebraic expression u. And if I had the absolute value of some algebraic expression u, and if it was less than or equal to some positive number 4, well, we know this sets up to say that u is greater than or equal to negative 4, and it's less than or equal to positive 4. So, okay, we just have to translate that here. So this is my u here. So I would say the absolute value of 2x minus 1, then plus 3, is going to be greater than or equal to negative 4, and less than or equal to positive 4. So this is going to be my setup. Now, because this is a three-part inequality, you can first subtract 3 away from each part. So remember, you have to do it to each part. I'm going to cancel that. Negative 4 minus 3 is negative 7. And we'll say this is less than or equal to. This is the absolute value of 2x minus 1, which is less than or equal to. 4 minus 3 is going to be 1. Now, you're going to break this up. Remember, when you have a three-part inequality, this is something you can write using the keyword and so things have to work in both when you have the keyword and. The first one here is going to be really simple. We have the absolute value of 2x minus 1, and then we're saying this is greater than or equal to negative 7. So it's greater than or equal to negative 7. Then I'm going to say and. We're going to say the absolute value of 2x minus 1, this is less than or equal to 1. Now this one right here, I think you can eyeball that and see that it's going to work for all real numbers, okay? Because the absolute value operation is always going to give you something that is 0 or positive, so basically non-negative. And so that is always going to be greater than some negative 7. So this guy right here is all real numbers. Let me just write this. So all real numbers. So then we have this keyword and. Okay, so basically, because this is all real numbers and there's an and here, I'm just going to take the solution from this one as the solution for the problem because it has to work in both. We have the absolute value of 2x minus 1, and this is less than or equal to 1. So this is going to split up into 2x minus 1 is greater than or equal to negative 1, and we'll say and less than or equal to positive 1. So this is pretty quick to solve. We're just going to add 1 to each part here. So basically, this cancels. And you get 0 is less than or equal to. This is going to cancel. You get 2x, and this is less than or equal to. 1 plus 1 is going to be 2. Now here you can divide each part by 2. And basically, let me actually just erase this. We don't need this information anymore. We'll say that 0 divided by 2 is 0, and this is less than or equal to. We have 2 over 2, which is 1, so this is x, which is less than or equal to. 2 over 2 is 1. So this tells me that x is going to be anything that's greater than or equal to 0 and less than or equal to 1. So basically, you would write this like this. So you say all real numbers from this one. Then you say and. You have x is greater than or equal to 0 and less than or equal to 1 from this one. Again, because you're using the keyword and, you have to use this one as your solution because it has to work in both. Okay, so coming down here, let me make this a little bit better. We would say in interval notation, so basically 0 is included up to and including 1. So you have a bracket next to each. And then this is going to be kind of tight to fit this here, but basically you want a bracket at 0 and a bracket at 1. Again, you can always use a filled in circle if that's what your book does. And then just shade everything in between. So x can be 0 or anything going up to and including 1. So graphically, a lot of programs won't actually do this or you'll get trouble with it. But I've sketched a little graph here just so we can think about it. So this part right here is just this guy right here, right? If you punch that in, you could even say that y is equal to the absolute value of 2x minus 1. And then basically you have plus 3. And maybe we'll make this a little bit shorter here. And then essentially you're saying, where is this less than or equal to 4? Well, again, look at the y values. Here's 4, right? So let me actually get rid of this. I think it's in the way here. So here's 4. And this is where it crosses, and this is where it crosses in terms of having a y value of 4. So come down here. This is an x value of 0, and this is an x value of 1. So you can see that if you're between 0 and 1, the y value is going to be less than 4. If you're at an x value of 0 or you're at an x value of 1, the y value is 4. Okay, so basically our solution, if you're saying, where's this guy less than or equal to 4, it's x is greater than or equal to 0, okay, so starting here, and then less than or equal to 1, so ending here. All right, let's take a look at problem number 7 now. So here we have the absolute value of x minus 2, then minus 3. This is less than or equal to 2. So again, another nested absolute value problem. So just think about this guy right here. the expression inside of the outer absolute value bars, again, you can just think about that as being u. So if the absolute value of u is less than or equal to 2, then u is greater than or equal to -2 and less than or equal to +2. So let's just write this out. So we would have the absolute value of x minus 2, then minus 3, and this is going to be greater than or equal to -2 and less than or equal to 2. Okay, so let's work on this now. So this is a 3-part inequality at this point. We're going to end up splitting it. But for right now, let me add 3 to each part to make this a little bit easier to work with. This will cancel. We'll have -2 plus 3, which is 1. And this is less than or equal to the absolute value of x minus 2. And then this is less than or equal to 2 plus 3 is going to be 5. Okay, so what I'm going to do now is split this up using my keyword and. So I'm going to say that the absolute value of x minus 2 is greater than or equal to 1. Then I'm going to say and the absolute value of x minus 2 is less than or equal to 5. So this is more challenging, or I would actually say more tedious than the last problem, because in the last problem, we had something with a solution of all real numbers, so we really only had to take the solution from the problem on the right. But here we're going to see that we have to do some combining. So on the left, if you have the absolute value of x minus 2 and it's greater than or equal to 1, you would say that x minus 2 is less than or equal to -1, or x minus 2 is greater than or equal to +1. So for this one, let's add 2 to each side. This would cancel. You get x is less than or equal to. If you have -1 plus 2, that's just going to be 1. And then over here, let's add 2 to each side. This will cancel. And you're going to get or x is greater than or equal to 1 plus 2 is 3. So that's for this one right here. Let me scooch this up here so we can keep this more organized. So you have x is less than or equal to 1 or x is greater than or equal to 3. Okay, but you've got this keyword and. So let's work on this. You have the absolute value of x minus 2, and this is less than or equal to 5. So this one has the setup where we say x minus 2 is greater than or equal to the negative of 5 and less than or equal to 5. Let's add 2 to each part here and cancel this. So let's say -5 plus 2 is going to be -3, and this is less than or equal to. You'll have your x here. We'll say which is less than or equal to 5 plus 2 is going to be 7. And I'm going to put the keyword and here. And this is going to be a little bit complex to figure out. So let's grab this. And let's start with this guy up top. So if you had x is less than or equal to 1, I'm going to use a filled in circle here. I normally don't do that. I normally use a bracket, but I'm going to do that in this case. And I'm going to shade everything to the left here. Okay. Then x is greater than or equal to 3. I'm going to come to 3, filled in circle, shade everything to the right. So thinking about this one, we have x is greater than or equal to -3 and less than or equal to 7. So at -3, I would put a filled in circle, and at 7, I would put a filled in circle, and I would shade everything in between. Okay, so now you're thinking about the intersection or the overlap. Well, this -3 would be included, and this 1 would be included, and then this 3 would be included, and this 7 would be included. But basically, it's just those areas, right? Let's get rid of this. We would shade between here and between here, okay? So let's get rid of this. I think we can see the solution graphically and then put it together. So basically, you would say that x is greater than or equal to -3 and less than or equal to 1. Then or x is greater than or equal to 3 and less than or equal to 7. Okay, so that's your solution there. And then in interval notation, you're going to put a bracket next to -3. This is going up to and including 1, so you want a bracket there. And the union with, again, everything's going to have a bracket, so the 3 and the 7, because they're both included. Okay, so this is your interval notation. Now, I like to use brackets when I graph these guys, so I'm just going to switch this over. This is a perfectly acceptable way to do this. It's just not the way that I'm used to. So I'm going to put a bracket at -3 and put a bracket at 1. And then I'm going to put a bracket at 3 and a bracket at 7 and just shade everything in between there. So graphically, x can be anything starting from -3, going up to and including +1, or it could be anything starting with 3 and going up to and including 7. So once again, thinking about this graphically, you can get rid of this part right here. And I'm just going to say that y is equal to this. This was the left side. And so basically, that's this graph here. And you want to see, where is it less than or equal to 2? So where is the y value 2 or lower? So we can see that if we go here, this is at -3. If we go here, this is at +1. If we go here, this is at +3. And then if we go here, it's at +7.
So you would see that between an x value of -3 and an x value of +1, the y value is 2 or less, right? So that's this part right here when you look at the graph, okay? So let me write x is greater than or equal to this -3. And we'll say and less than or equal to 1. Now, as you move to the right here, between 1 and 3, right, not including either one, you're going to be above 2. But then when you hit 3, you're at 2 in terms of the y value. And then as you continue to the right, as your x values increase, going up to and including 7, you're going to either be below 2 or equal to 2 when you get to 7, right? So you can say again, or x is greater than or equal to, again, this 3, and less than or equal to 7. All right, let's take a look at problem number 8 now. So here we have the absolute value of x squared plus 3x minus 4. And this is less than or equal to 6. So again, we didn't do an example of this in the lesson, but we can just use our rule. We say the absolute value of u is less than or equal to 6, where u is x squared plus 3x minus 4. Well, then u is going to be greater than or equal to -6 and less than or equal to 6. So just set this up and say that we have x squared plus 3x minus 4. That's going to be in the middle. We'll say this is greater than or equal to -6, and then and less than or equal to 6. Okay, what I'm going to do, since this is a 3-part inequality, I'm just going to add 4 to each part. I think that's going to make it a little bit easier. So this is going to cancel, and you'll have x squared, then plus 3x. We'll say this is greater than or equal to -6 plus 4 is going to be -2. And then over here, 6 plus 4 is going to be 10. So we'll say this is less than or equal to 10. So I'm going to split this up using the keyword and. So I'm going to first say that x squared plus 3x is greater than or equal to -2. Let me slide this over a little bit. And then I'll say and. We'll say that x squared plus 3x is less than or equal to 10. Let's start out with our guy on the left. And what I'm going to do is just add 2 to both sides of the inequality. So this is x squared plus 3x, then plus 2 is greater than or equal to 0. And then for this guy here, I can factor this. If you want two integers whose sum is 3 and whose product is +2, well, that's 2 and 1, right? So I can say this is x plus 2, that quantity times the quantity x plus 1, and this guy would be greater than or equal to 0. We know if we solve a quadratic inequality, the first thing you do is find the critical values. So you can just factor this like this. So x plus 2 here, and then x plus 1 there. And we'll just say this is equal to 0. So you would say x plus 2 is equal to 0. You would solve that. You get x is equal to -2. You would say x plus 1 is equal to 0. You solve that. You get x equals -1. Okay, so let's grab everything. You want to come to your number line. You don't need this anymore. So then that's your critical value of -2. Let's put a vertical bar. And then also at -1. So anything less than -2, let's say that's A. Between -2 and -1, that's B. And anything greater than -1, that's C. So you have A, B, and C. So you're just going to test inside of each. So we know here, because this is non-strict, that -2 and -1 would be included. But let's just think about something that's in A. So let's pick -3. So -3 plus 2 is going to be -1. And then -3 plus 1 is going to be -2. The main thing here is that it's a negative times a negative, which is a positive, which is always greater than 0. So this is true. You could also just say that -1 times -2 is 2, and 2 is greater than 0. So that's good to go. Okay, so for B, we're between -2 and -1. Now you could use something like -1.5. And again, if you don't want to go through the calculation, just say, is it going to be negative or is it going to be positive? Well, -1.5 plus 2 is +0.5. So let's just say this is positive. And then -1.5 plus 1 is -0.5, so this is negative. Positive times negative is negative, and a negative is not going to be greater than 0 or equal to 0, so here it's going to be false. Now in C, we can use 0, and so this would be +2, and this would be +1, so it's 2. Again, you can just think about the fact that this is positive times positive, which is positive, and a positive is greater than 0. You can say 2 is greater than 0, however you want to think about this, but this is true, okay? So we know that for the solution for this inequality now, that basically x can be anything that's including -2 or less, so x is less than or equal to -2, then or x could be anything that includes -1 or is greater, so greater than or equal to -1. Okay, let's grab this, and I'm just going to come back over here and put this right here. I'm going to use my keyword and then I'm going to look at the solution for this one. So let's put this down here. We're going to have x squared and then plus 3x. I'm going to subtract 10 away from each side.
So minus 10, this is less than or equal to 0. And let's just factor this. I think it's a little bit easier that way. So let's put an x here and an x here. And let's think about two integers that sum to 3 and have a product of negative 10, where you can go positive 5 and then negative 2, right? So if you set this up as this quantity x plus 5 times the quantity x minus 2 is equal to 0 to get the critical values, you solve x plus 5 equals 0. Well, that's going to be x is equal to negative 5. And then you solve x minus 2 is equal to 0. That's going to be x is equal to 2. So let's grab everything. And coming down here, we don't need this anymore. You get rid of that. Your critical values here, you've got 1 at negative 5. And then you've got 1 at positive 2. So let's say this is A, this is B, and this is C. So let me write out A, B, and C. So let's first start out in A, and I'm just going to pick, let's say, negative 6. So again, you can just work with the sign if you want. So you'd have negative 6 plus 5, that's negative 1. And then negative 6 minus 2 is negative 8. Again, negative times negative is positive. And a positive is not less than 0, and it's not equal to 0. So we would say here, this is going to be false. Again, if you wanted to say negative 1 times negative 8 is 8, and 8 is not less than 0, that's another way you could do it. Okay. In B, I'm going to pick 0. So this is 5, and then this is negative 2. Positive times negative is going to be a negative, and a negative is always less than 0, so this is true. Or again, you could say this is negative 10, and that's less than 0. It's true either way. Okay. For C, you could pick 3. So 3 plus 5 is 8. And then 3 minus 2 is 1. And again, this is going to be a positive, and that's not less than 0, so this is false. Okay. Again, you could always say that this is 8, and 8 is not less than 0. So let's write our solution. Here, it would basically be that x is greater than or equal to, it would be equal to negative 5 because this is non-strict, and less than or equal to this 2, again, because it's non-strict, the 2 would be included. Let me stack this up here so that it fits, and let me paste this in here. Okay. So let's consider this. Remember, this is an and for the whole thing. So I'm just going to grab this and go back to the number line, and we're going to think about where this works. Okay. So first off, I'm just going to graph this. So x is less than or equal to negative 2. So let me put at negative 2, I'm just going to put a filled in circle. I don't normally do that, but for this one, I think it's easier. And I'm going to shade everything to the left. And then for negative 1, let's use a filled in circle there. And then since it's a greater than or equal to, let's shade everything to the right. For the other guy, you have x is greater than or equal to negative 5 and less than or equal to 2. So at negative 5, I would put a filled in circle. At 2, I would put a filled in circle. And again, I would just shade everything in between. Now, where's the overlap or the intersection? Well, this negative 5 would be a filled in circle there. This 2 would be a filled in circle there. And then basically, what I would want to do is grab those guys in between, right? So let me get rid of this. And so I'm just going to shade between negative 5 and negative 2, and between negative 1 and positive 2. So our solution, if you wanted to write it, you would say x is greater than or equal to negative 5 and less than or equal to negative 2. Then you would say, or this would also work if x was greater than or equal to negative 1 and less than or equal to 2. Okay, so this would be our full solution here. In interval notation, you would just put a negative 5 next to a bracket, then comma negative 2 next to a bracket. They're both included. And the union with, let me make that symbol a little bit better. So we would have a negative 1 next to a bracket, and then comma a 2 next to a bracket. Okay. Now graphically, we have this already. I prefer to use a bracket versus a filled in circle. If you like the filled in circle, you can stick with that. It's just not what I usually do. So I want a bracket at negative 5 and a bracket at negative 2, and then a bracket at negative 1 and a bracket at 2. So let me make this a little bit better. I'll just use this same color. So basically, x can be any number that is negative 5 and going up to and including negative 2, or any number that starts with negative 1 and going up to and including positive 2. Okay, so once again, I'm just going to look at the graph with you. We have graphed the left part of this. We're trying to figure out where that's less than or equal to 6. So let me just say that this right here, you could just punch this into Desmos, or you could say y is equal to this. Either way, it'll give you the same graph. But essentially, you see a y value of 6 here. And let me put everywhere where it intersects. So here, and here, and here, and here. And so if you're thinking about where this guy is going to be less than or equal to 6, well, it's equal to 6 at an x value of negative 5, at an x value of negative 2, at an x value of negative 1, and then at an x value of 2, okay? So less than negative 6, you would say between negative 5 and negative 2. So x is greater than or equal to negative 5,
and less than or equal to -2. And then between -2 and -1, you can see it goes above 6, right? So we're not interested in that piece. We're interested in this piece here, though, starting at -1 and then going out to and including this +2, right? Everywhere there, it would be either 6 or less than 6. So we'll say, or, again, x is greater than or equal to this -1 and less than or equal to +2. So that's how you can get your solution graphically. Again, we're interested in everywhere where this guy is going to be less than or equal to 6. So that part right there, and then also this part right here for your graph. All right, let's take a look at problem number 9 now. So here we have the absolute value of 5x minus 2. This is over x minus 1, and this is greater than 1. So we're going to use our rule and say if we have some algebraic expression u, and that's greater than some positive number, let's just use 1, then here u is going to be less than -1, or u is greater than 1. So we're just going to use that here, and we'll take this guy, which is the 5x minus 2, over x minus 1, that'll be our u. So we'll say it's less than -1, then or, we'll grab this guy again, so 5x minus 2 over x minus 1, and we'll say it's greater than 1. Okay, so now that we have this set up, we know that this is a tedious process. We have to solve 2 of these guys. I'm going to start with the one on the left. Remember, you want to get one single rational expression on the left, and you want 0 on the right. Okay, so that's the first step. So I would add 1 to both sides of the inequality. I would say this is 5x minus 2 over x minus 1, and then plus 1, and this is less than 0. So I just added 1 to both sides. Now, you need to get a common denominator going, and since this is 1, I can just multiply by x minus 1 over x minus 1. So in other words, I can just write this as x minus 1 over x minus 1. And since we have a common denominator now, I can actually just get rid of this and just extend this and just go plus here. So simplifying this, 5x plus x would be 6x. And then -2 minus 1 would be -3. Let me actually just erase this, and I'm just going to write this more neatly up here. So the numerator is 6x minus 3, and your denominator is just the x minus 1. Okay. When we think about this, we want to find the critical values. So this is where the numerator is going to be equal to 0 or the denominator is equal to 0. So we say 6x minus 3 is equal to 0. We solve that. And basically this gives us that 6x is equal to 3. Divide both sides by 6. This cancels. You get x is equal to a half. Okay, so that's your first critical value. Now, if we had a non-strict inequality, this would be part of your solution. You could just notate that if you want. Because this is a strict inequality, here when you plug this in, this 1/2, the numerator is 0, the denominator is not 0, so 0 over some non-zero number is 0, and you get 0 is less than 0, which is a false statement. Okay, so this is not going to work as a solution. And the other guy, where we say x minus 1 is equal to 0, the solution here, if we add 1 to both sides, we're going to say x is equal to 1. Now that guy right there is definitely not going to be a solution because that results in division by 0, right? So if we made a domain statement, we would say it's the set of all x such that x is not equal to 1. Okay, so let's grab this real quick, and we'll just come to a little number line and test. I'll say this is 1/2 and this is 1. You can get rid of this now. And again, we know they're both not going to be included. And you could factor this. This would be 3 times the quantity 2x minus 1. So let me write this like this. So 3 times the quantity 2x minus 1. Just easier to plug stuff in. So let's say this is A, anything less than a half. B is between a half and 1, and C is greater than 1. So we have A, B, and C. And let's first test an A. So I can pick 0. So 2 times 0 is 0. So basically you would have -1 times 3, which is -3. This would be over. You have 0 minus 1, which is -1. And so a negative over a negative is a positive. And so a positive is not less than 0. So this is false. And again, you can always just say that -3 divided by -1 is 3. 3 is not less than 0. Whatever you want to do. So for B, I need something between 1/2, or you could say 0.5 and 1. You could pick 0.75. I know that's hard to work with, but let's just use a calculator. So let's just say that's 0.75. You could also say 3/4. Let's go 0.75 there. So 2 times 0.75, that's 1.5. Then minus 1 is 0.5. Then times 3 is 1.5, right? So you could say 3/2 or 1.5, whatever you want to do. Then this is over. Let me actually just get rid of this. 0.75 minus 1 is -0.25. Now, you don't even need to know what the result of this is because you know it's going to be negative, right? And a negative is always less than 0, so this is true. if you did punch this into your calculator, you would get -6. So you could just say -6 is less than 0. That's a true statement. So either way. Then for C, let's just pick 2. So 2 times 2 is 4. 4 minus 1 is 3. 3 times 3 is 9. And this is over 2 minus 1. That's going to be 1. So this is 9, or a positive value. And that's not going to be less than 0. So this is false. So your solution here is between 1/2 and 1 with neither included. So we'll say x is strictly greater than 1/2 and strictly less than 1. Okay, coming back here. So I'm going to put that as the solution for this one. And then we're dealing with this one now. So let me put my keyword or. So I'm going to have this 5x minus 2 over x minus 1. Now I'm going to subtract 1 away from each side of the inequality. So minus 1 over here is greater than 0. So this, again, you could just write as x minus 1 over x minus 1. Because this is subtraction, let me take the time to do an additional step here because a lot of people get lost. So let's say this is 5x minus 2 and then minus the quantity x minus 1. Because this whole thing needs to be subtracted away. So I'm going to put the subtraction sign and then put the x minus 1 inside of parentheses. Then this is over the common denominator of x minus 1, and this is greater than 0. All right, so let's write this as 5x minus 2, and this would be minus x and then plus 1. So 5x minus x would be 4x. So this is 4x, and then negative 2 plus 1 would be negative 1. So this is 4x minus 1 over x minus 1. And again, this is greater than 0. So what are the critical values here? Well, we would set the numerator, 4x minus 1 equal to 0, and solve that. Let's add 1 to each side. This would be 4x is equal to 1. Divide both sides by 4. Let's cancel this and say x is equal to 1/4. So that's one critical value. And again, this is going to be excluded because this is a strict inequality. You would end up with 0 is greater than 0, which is false. So let's put this over here. The other one is the x minus 1 that we saw earlier. If we set that equal to 0 and solve, we get x equals 1. So x equals 1. And remember, this is automatically excluded because it makes the denominator 0, so it would violate the domain. So let's grab this. So we'll come down here and test. So this is 1/4 and this is 1. So let's think about this as A, so anything less than 1/4. This is B, anything between 1/4 and 1. And this is C, anything greater than 1. Okay, so in A, you could pick 0. And again, you could just think about the sign. This is really easy. This would go away. You'd have -1 or just a negative over. This would be -1 or just a negative. And a negative divided by a negative is a positive. And a positive is always greater than 0. So for A, this is going to be true. Again, if you want to calculate the value, you can do that as well. This would be -1 over -1, which is 1. And 1 is greater than 0. So either way. Now for B, I would just use something like 1/2, or you could say 0.5. So 4 times 1/2 is 2, and then 2 minus 1 is 1. So you could say it's 1, or you could just say it's positive. Then additionally, if I did 1/2 minus 1, that's -1/2. More importantly, it's negative, right? So positive over negative is negative. A negative is not greater than 0, so this is false. Again, if you want to calculate that, 1 divided by -0.5 would be -2, and that's not greater than 0. Okay, for C, let's just use 2. So 4 times 2 is 8. 8 minus 1 is 7. Or again, you could just say it's positive. And this is over. 2 minus 1 is 1, right? So you would say positive over positive is positive. That's greater than 0, so this is true. Or you could just say 7 over 1 is 7. 7 is greater than 0. That's true. So either way. So we know that the solution here would be anything where x is less than 1/4 or anything where x is greater than 1. Okay, let's grab this. And we'll paste that in there. And basically, this is our solution. So putting this together, it might be more helpful to graph it before you do your interval notation. So if you look through, you're going to see 1/4, 1/2, and 1. Okay, so you need a notch for 1/4, you need a notch for 1/2, and you need a notch for 1. So if you're using something generic like this, don't worry too much about the spacing. Just make sure it's in the order of the number line. So in other words, 1/4 is the leftmost value, 1/2 is the middle value, and 1 is the rightmost value or the largest value. So now thinking about this part right here tells me that x is less than 1/4. So let me just start with that. Graphically, I would put a parenthesis at 1/4 to show it's not included, and I would just shade everything to the left. So that takes care of that. Then I'm going to say or. I'm just going to get rid of stuff as I go. You have this part right here where x is greater than 1/2 and less than 1. Okay, so what does that look like? Well, I would put a parenthesis at 1/2, and I would put a parenthesis at 1. That color's not going to show up there, so let me change. And then I would shade everything in between here. Okay, so that would be that part there. Then you have this or. Let me get rid of this so far. You have x is greater than 1. So x is greater than 1. Okay, so for that one, let me use a different color here, maybe this red. And so I'm going to put a parenthesis facing to the right here, and then I'm just going to shade everything to the right. So 1 is excluded, and if you go back to your original rational expression, remember the denominator was x minus 1, and if x minus 1 was set equal to 0, you get a value of 1. In other words, if you plug 1 in, you're going to get division by 0, and that's not defined. If we come to the graph, you're going to see at 1, you have this strange behavior where the graph is going to approach an x value of 1, but it's never going to quite get there. Okay, and this is called an asymptote, and we'll talk about this later on in the course. For right now, let's go back, and let's think about this guy in interval notation. So basically, I would start with this one. So you have from negative infinity going up to and excluding 1/4, so a parenthesis with each. And then the union with, you have anything between 1/2 and 1. So basically a parenthesis next to 1/2 and a parenthesis next to 1. And then basically a union with anything that's greater than 1. Okay, so a parenthesis next to each. So nothing here, when you go through, is actually included. That's why there's a parenthesis basically everywhere. And if you wanted to replace this with an open circle instead of the parenthesis, that's fine in each case, right? So that's what a lot of books will do. I'm just used to this notation. So this would be your full answer. This is graphically, so anything less than 1/4, or anything that's between 1/2 and 1, or anything greater than 1. All right, so additionally, if you want to come back to this graph and think about it, if you punch in this guy right here, this left side into Desmos, or you could just say that y is equal to this, it'll produce the same graph. Essentially, you're looking for where the y value is greater than 1. Not equal to 1, but greater than 1. It would be equal to 1 here and also here, right? So essentially, if you come down here, and this is not going to be perfect, this x value here is 1/4. And then this guy coming down here, this is going to be 1/2. And so essentially, you'll see that anything to the left of an x value of 1/4, well, the y value here is going to be greater than 1. So that's where we got the x is less than 1/4 part. Then we said or. Well, here, anything that's greater than 1/2, you can see that the y value would be greater than 1. But there's a problem. We keep going up, up, up like this because, again, at an x value of 1, you're dividing by 0, right? So that's why we can never actually obtain an x value of 1. So you have to say that x is greater than 1/2 and less than 1, right, to account for that fact. But anything greater than 1 starts to work again. Okay, so we're just going to exclude 1. So we'll say or x is greater than 1. So that's how you could get your solution graphically. Again, you can always just use something like Desmos to see this for yourself. All right, let's take a look at problem number 10 now. So here we have the absolute value of 2x minus 9 over the absolute value of x plus 3. This is less than or equal to 1. Now, the first thing I'm going to do is use a rule that we talked about earlier in the course. So if we have something like the absolute value of a over the absolute value of b, this can be written as the absolute value of a over b. Okay, so we're going to make this little change here. So we'll say this is the absolute value of this 2x minus 9 over the x plus 3 here. And we'll say this is less than or equal to 1. So now we're going to use a different rule. So if we had the absolute value of u, and we said this is less than or equal to 1, well, that means that u is greater than or equal to -1 and less than or equal to 1. Okay, so I'm not going to write this as a 3-part inequality. I'm going to break it up and use the keyword and. I think that's going to be a little bit better here. And so I'll take this guy, this 2x minus 9 over x plus 3, and I'll say that it's going to be greater than or equal to -1. And then I'll say and this 2x minus 9 over this x plus 3 is going to be less than or equal to +1. All right, so we're just going to solve each part separately, and then we'll join our two solutions with and. So for this one, I would add 1 to both sides of the inequality. You're going to get 2x minus 9 over x plus 3, and then I'll go plus 1 here, and that's greater than or equal to 0. Now let me slide this down. This is pretty easy. If you just have a 1, well, then I can multiply this by x plus 3 over x plus 3 so that I have a common denominator. That's pretty straightforward. And then basically 2x plus x would be 3x. So this is 3x. And then -9 plus 3 is going to be -6. And this is over your common denominator of x plus 3.
And let's think about our critical values now. So you'd set the numerator equal to 0. So you'd say 3x minus 6 is equal to 0. Add 6 to both sides of the equation. This cancels. We get 3x is equal to 6. Divide both sides by 3. You get x is equal to 2. All right, so that's one critical value. We'll say x is equal to 2. And I would note here, because this is non-strict, that 2 is going to work. The other guy, you'd set x plus 3 equal to 0. You'd solve that. You get x is equal to negative 3. We know that this is not going to work because this would result in division by 0. So let's go to the number line now, and we're just going to test. Now, you could factor this to make it a little bit easier. So if you pull out a 3, you'd have x minus 2 inside. Again, it's not necessary, but just something I like to do. So 3 times the quantity x minus 2. And then essentially you have the critical value here of negative 3, and then 1 of 2. And then let's go ahead and set up this and say this is A, so anything less than negative 3. This is B, between negative 3 and 2. And this is C, anything greater than 2. So thinking about this, I'm going to start in A, and I'll just pick something like maybe negative 4. I think that'll be easy to work with. So negative 4 minus 2 is going to be negative 6. And then negative 6 times 3 is negative 18. This is over. If you have negative 4 plus 3, that's going to be negative 1. Now we know that a negative over a negative is a positive, so this is basically a positive 18 here. And of course, a positive is always greater than 0, or you can say 18 is greater than 0, so this is going to be true. Okay, for the next one, you're going to be between negative 3 and 2, so you could pick 0. So 0 minus 2 is negative 2, and negative 2 times 3 is negative 6. And this is over. Here, this would go away. You just have 3. So negative 6 over 3 is negative 2. So this is negative 2 is greater than or equal to 0, which is going to be false, right? So you could say that any negative is never going to be greater than 0 or equal to 0. So that's why that's not going to be true. Okay. For C, you could pick 3. It's anything greater than 2. So 3 minus 2 would be 1. 1 times 3 is 3. And this is over. If you have 3 plus 3, that's 6. So 3 over 6 is going to be a half. But more importantly, it is a positive value, so it's greater than 0. So this is going to be true. Okay. We're going to get rid of this. And I want you to recall that 2 is part of the solution, but negative 3 is not. So we're going to say that in region A, things are going to work, but negative 3 is not included. So x is strictly less than negative 3. Then or. In region C, things are going to work, and 2 is included. So x is greater than or equal to 2. Okay, so let's put this in right here. And then I'm going to write my keyword and we're going to think about the solution for this guy right here. So let me write this. So we have 2x minus 9 over x plus 3. I'm going to subtract 1 away from each side. So minus, and I'm going to write 1 as x plus 3 over x plus 3. So I have a common denominator, and this is less than or equal to 0. What you want to do here is write 2x minus 9, then minus this quantity here. Okay, you're subtracting the whole thing away. So the quantity x plus 3, and this is over your x plus 3. Let me make this 3 better. And then we'll say this is less than or equal to 0. Okay, I'm going to get rid of this. And so this would be negative x and then minus 3. So 2x minus x is x. And then negative 9 minus 3 is going to be negative 12. And this is over your x plus 3. So your x plus 3. And of course, this is less than or equal to 0. Now, for the critical values, if you put x minus 12 equal to 0 and you solve that, you get x equals 12. And we already know this one. This is x is equal to negative 3. Now, 12 is going to work because this is a non-strict inequality, but negative 3 is still not going to work because that's division by 0. So coming back down here, let's put this as negative 3. Let's put this as 12. Let's get rid of this. And let's say this is A, B, and C. So A, B, and C. So let's see what we have here. All right, for A, let's maybe pick negative 4. So negative 4 minus 12 is negative 16. This is over negative 4 plus 3. That's going to be negative 1. So is this less than or equal to 0? Well, this is going to be a positive 16. So basically, a positive number is never less than 0 or equal to 0. So this is going to be false. Then for B, you could pick 0. So this is negative 12 over 0 plus 3 is 3. So if you do the division here, you're going to get negative 4. So negative 4, is that less than or equal to 0? Yes, any negative is less than 0. So this is true. Okay, for C, let's pick 13. So 13 minus 12 is going to be 1. And this is over 13 plus 3 is 16. So this is going to be a positive value, and that's not going to be less than 0 or equal to 0. So this is false. Okay, let me get rid of this. I want you to recall that 12 is going to work and negative 3 is not. So we want things in B. So basically x is strictly greater than negative 3 and less than or equal to 12. So let's grab this. Let's bring this back here. Let me move this word and down here. So basically, we're going to think about this with a number line. So we're going to have
three values that I'm going to put up here. So one is -3, the other is 2, and the last one is 12. Okay, so let me think about this one first. So you have x is less than -3. So let me just draw that out. I'm going to use an open circle here. I don't typically do that, but for this purpose, I think it's probably better. Then you have x is greater than or equal to 2. So let me put a filled in circle there because that's included. And then let me shade everything to the right. Okay, so that's this one right here. Now let's think about this one right here. So here we're saying that x is greater than -3. So greater than -3 and less than or equal to 12. So let me put this in right there, and I need a different color. Let me get rid of that and make this a little bit better there. And then I'm just going to shade everything in between there. Okay, so you want to think about the overlap here. And essentially, looking to the left of 2, there is no overlap. You have this guy up here, which is between -3 and 2, which is not a solution in the other one. And the other one is anything to the left of -3. So this part of the graph, you can forget about it. There's no overlap between the two. And then past 12, there's no overlap. So basically, you're looking between 2 and 12, with 2 and 12 being included. So that is what I want if I'm thinking about my solution. Let me maybe use a different color because that's not showing up so well. So you want between 2 and 12, right? That's going to be your overlap between the two solutions. That's what you have to do when you have the keyword and. So what we're going to say, just erase this, you don't need it, that x is greater than or equal to 2 and less than or equal to 12. So both of these are going to be included. And let me use a bracket here. I'm just going to change the color up completely. So let me use this color. I'm going to use a bracket at 2, or you can keep the filled in circle, and a bracket at 12, and I'm going to shade everything in between. So x can be any number, including 2, and going up to and including 12. In interval notation, it looks like this. So you'd have a 2 here with a bracket, and then a 12 here with a bracket. All right, so once again, this is something you want to look at graphically as well. So we're looking for where this guy is less than or equal to 1. So let me put y is equal to this. This is going to produce this graph, or you can just type this into Desmos without the y equals if you want. But look at where it's equal to 1. So you see this one right here, the x value is 2. That gives me a y value of 1. And then also at an x value of 12, that gives me a y value of 1. So anywhere between an x value of 2 and an x value of 12, you're going to have a y value that is less than this 1. Okay, so if you wanted less than or equal to 1, then you would include 2 and 12. So we say x is greater than or equal to 2 and less than or equal to 12. So again, if you're lost on these problems, just go to Desmos or any online graphing calculator, key this in, and look for where it's less than or equal to 1 in terms of the y value.